You should see my slides at this moment. Every now and then I will tell you what I expect you to see. If at some point during class I expect you to see something, you don't see it, please do let me know. Our primary way of communicating is a chat window. I have the chat window open at all times. So if you put something in the chat window, then you will have my immediate attention. So again, welcome everybody and welcome to this class. This is an EX280 pre-release course. Now, what does that mean? Well, that means that my name is Sander van Vugt and I am currently developing a course for EX280. Just so that it is clear, I am not related to Red Hat in any way. Red Hat does not authorize nor approve or anything. I'm doing this on my own together with Pearson Education, which is my publisher. Pretty soon I am going to record the contents of this course to make it a new video course. And I thought, well, OpenShift is a complicated topic. And I want to make sure this video course is as good as it can get. And I wanted to do a test teach before recording, just to fine tune it a little bit and get some feedback as well. So that is where we are. Let's talk a little bit about expectations. So this is a pre-release course, and that means that things will go wrong and things might be incomplete in this course. Obviously, I've done my best to make it as good as possible, but hey, a pre-release course, well, I think you get the idea. Here is the deal. I provide my knowledge for free. You provide your feedback for free. So I do think it's very important. If anything doesn't work out for you in this class, I would like to know. If there's anything you don't understand in this class, I would like to know. I am teaching courses like this on O'Reilly, sometimes with as much as 300 people attending class. And it does happen that nobody is saying anything during the entire class. I hope this class will be different. I have some expectations. First, you are expected to have your own OpenShift or OKD installation. I would prefer if you are using code-ready containers. Every single one of you has received a message from me telling you that I expect you to work with code-ready containers. Why code-ready containers? Well, in the different choices that we have in working with OpenShift, code-ready containers is the only one that is more or less doable regarding hardware, and that is stable enough to run in your own environment. I have tried the single node OKD cluster, but setting up a single node OKD cluster is no fun, and I'm getting different results under the same circumstances. So that is why this course will be based on code-ready containers. And yes, it will be a one single node OpenShift cluster. So I expect you to have access to code-ready containers for the hands-on parts. I also expect you to have installed that already. I don't want to spend any time on getting you up and running with code-ready containers. Also, I expect you to know about Kubernetes fundamentals. If you came to this class with the expectation of learning about the differences between pods and deployments, that is not going to happen. In this class, we need to continue on top of your Kubernetes basics knowledge. So I don't have time to explain Kubernetes basic concepts in this class, and I will ignore you if you are asking very basic questions. Just to make sure that we can focus on the core contents of EX280. As you probably all know, EX280 is the OpenShift administration course that is offered by Red Hat. And in this OpenShift administration course, you are supposed to be doing administrative level tasks in an OpenShift cluster. EX280 is what is coming after EX180. EX180 is the OpenShift introduction course. We are not doing 180 here, we are doing 280. In case you are thinking, hey, isn't that the wrong order? Well, maybe that is the wrong order, but I wanted to record this course first. There is already quite some stuff available on the market, including my own video course about OpenShift basics, and there is nothing that goes beyond the OpenShift basics. This is a pre-release course. If you want to access the final version, there is two things that I can do for you. On a request, once the final version is available, and that won't be before early May probably, you can get a 70% discount when the final course is available. I can't give it away for free. That is because I'm not producing it myself. I can only give you the maximum discount. Or even better, access it through learning.o'reilly.com. Can I just have a quick question, and please answer in the chat. Are you on learning.o'reilly.com? Please say yes or no in the chat. I just want to make sure that if I talk about it, okay, that's about maybe half of you. Good. I'm not getting anything for getting you on learning.o'reilly.com. I can see that more than half of you is probably not on learning.o'reilly.com, but I think learning.o'reilly.com is the best way to consume my products, including this one. It's flat fee, $500 US dollars. If you take the effort of looking for a discount code, it will be cheaper, and you have access for 1 year to everything that I'm doing. And if you take more than, let's say, 2 classes in a year, it's the more beneficial offering. All right. Your feedback. So your feedback is important to me. First, feedback should be constructive. Smart-assing is not permitted. Now, what is smart-assing? Smart-assing is if I say something, if I explain something which is not wrong. Sometimes there are people who want to explain it their way. That is just time consuming, and please don't do it. If you think that what I say is nonsense, please let me know. I'm only human, and this is pre-release course, and maybe I miss the point in your opinion every now and then. Then please share your feedback. But let's try to make the feedback to the point and constructive, so that we don't waste another's time, and you can help me telling you a better story. For quick feedback, please use the chat. It's a chat window that you can see right here. For more extensive feedback, use mail@sandervanvugt.nl, which is my email address. If you do want to talk, please ask first in the chat. Do not open your microphone without asking first. Just to be sure that we can move on with this course in an efficient way. I have not even enabled your microphones. You are all muted. But if it is necessary, please let me know that you would like to open your microphone, and we can do through the microphone. Just to give you some background of why I'm not opening the microphones by default. Given the quality of the internet connection, given the location where people are from, given the weird accents that people are using, including mine. I'm from the Netherlands, by the way. That explains why I have a weird accent. Sometimes it is very hard to understand what people are asking, and that is why I rather have you type your question in chat. But if it is necessary, we can always open the microphone. Thank you, Nazar. Course agenda, what are we going to do? I'm so happy to see that everybody is here, especially Etienne from New Zealand. It must be in the middle of the night in New Zealand right now. So great to have you here, Etienne. So the course times, we are 2 days, 2 p.m., 7 p.m. in Amsterdam time. You made it on time, and I'm so happy to see that everybody is in more or less at the expected time. So we do 2 p.m., 7 p.m. That is 5 hours. We will have breaks during the course. Normally, I'm trying to do a break on top of every hour. And that's probably what's going to happen here as well. But it may happen that I need to do something, and at the same time I can schedule a break, and I don't know exactly how it is going to work. But doing this in 5 hours in a row means that we don't have big chunks of time where I can tell you in advance, hey, in 3 hours from now, we will have a break. This is a pre-release course. This is a beta course, basically, and I'm not really sure what is going to happen, which is why I'm doing this course. So programs, the topics for today, we are going to start slowly. With understanding OpenShift clusters and managing OpenShift clusters and managing OpenShift resources and managing OpenShift storage. These are the topics for today. We might find that by the end of the day, we will also make a start with configuring authentication. Topics for tomorrow: configuring authentication, managing RBAC, managing OpenShift networking, managing pod scaling, and scheduling. The purpose of this course is to make sure that you are getting ready for EX280, and these are the topics that you need to know about for EX280. For your information, I have done EX280 myself, and I failed because it was a surprising exam. But hey, I don't care failing. I rather do the exam 3 times so that I know everything that is in the exam and I can tell people about it. Also, for your information, I'm not going to tell you which questions are on the exam. That would violate my non-disclosure agreement, and I don't want to do that. I think people should deserve getting certified for EX280. I can already tell you that the things that are heaviest for EX280 currently in the program are all scheduled for tomorrow, which is why I am going to try to forward configuration of authentication a little bit. There's a lot of stuff to be discussed in authentication, in RBAC, in OpenShift networking, in pod scaling, in scheduling. It might help if we do a little bit of that today. Just my curiosity, did any one of you already take EX280? Can you say yes or no in the chat? Okay, that seems to be a nobody. And thank you very much for being reactive, everybody. I really like being reactive, you being reactive in this way, so that we can actually work together instead of me talking to a computer screen, not giving you anything. Oh, and there's one more thing, and that is Living Open Source Foundation. Here's a nice QR code. I will leave the QR code up and running a little bit. Just as a background, when I started thinking about this course first, I thought, let me ask for an entrance fee to make sure that I have serious people only. Then I changed my mind and I thought, no, because if I'm going to ask for an entrance fee, then I am obliged to offer you something that is perfect. This is probably not going to be perfect, just good. So this course is free. If you want to do something in return, have a look at Living Open Source Foundation. As Living Open Source Foundation, we provide education in Africa for free. Not exclusively Africa. I'm always open for somebody coming in from another country who thinks that we should go to their country as well. And that is Living Open Source Foundation. Open source professionals should not just be from Europe, North America, and India. People in other countries should have a chance as well. Please consider making a donation. Everything you can miss is highly appreciated. I won't talk about it too much anymore because really we need to focus on the course topics. But hey, you will see this QR code coming along every now and then. Oh, also for your information, the course materials that I am using, the slides, are available in the materials section in the interface. So you can download the slides so that you can use them later yourself. Okay, I need access to my new slides, which is the lesson 1 slides. I only PDF'd lesson 1 through 5. I'm still fine-tuning contents of lesson 7 and lesson 8. That will be done by tomorrow, but that is why you don't see them around yet. Does anyone have any question? If you have any question, this would be a very nice moment to ask your question. And if not, then I am going to start and talk about the OpenShift product offering. I will give you a moment to give you the opportunity to ask questions in case you have anything. If you do have a question, just say yes in chat so that I know that I should wait for a little bit. And if you don't, then you don't have to say you don't have any question. Then that is just okay. All right. I think you don't have any questions so far, so that is good. Let's continue, and let's start talking about first part, understanding the OpenShift product offering. This is probably the part where, given the requirements for you to attend this class, where you are going to be a little bit bored, but I need to tell you about the product offering anyway. Just imagine that not everybody who is sitting this class, and I think this applies to you guys as well, not everyone has done EX180. Some people will jump into EX280 immediately, and for that reason I do need to include a little bit of basic topics about the product offering and so on. This is the copyright slide. Just to make sure that we understand each other. I love it that you are here in class, and please don't distribute the slides. This is work in progress. It's not good enough to distribute, and it's my work. It's not freely distributable. I do this for a living, and yeah, you don't work for free. That's the same with me. So please do not distribute. And here, the QR code, in case you missed it, I would say scan it. Please do have a look. Living Open Source Foundation, that is, obviously. Right, we are going to talk about OpenShift offerings. We need to understand where OpenShift is coming from and how we can use it. So OpenShift, also known as Red Hat OpenShift Container Platform, is an extension to Kubernetes with features that are commonly needed in the corporate data center. First and foremost, OpenShift is a Kubernetes platform. It's a very specific Kubernetes platform, but in the heart it is Kubernetes. That's also why I ask you, please come in with your current Kubernetes knowledge. We will see where OpenShift and Kubernetes are the same and where they are different later. But for now, most important is to understand that it is Kubernetes. When you are going to look at OpenShift, you will find that there are many OpenShift offerings, and we need to talk about the OpenShift offerings a little bit. To start with, there is Red Hat OpenShift Container Platform, which is a platform that is managed by the customer to provide OpenShift service on physical or virtual infrastructure on-premise or in cloud. So RHOCP is something that you can install in your own environment, in your own data center. You can run it in cloud environments as well. Red Hat OpenShift Container Platform is what we run in the user-provided infrastructure. UPI is how they call that in the documentation. There is Red Hat OpenShift Dedicated, which is a Red Hat managed cluster, which is offered in AWS, GCP, Azure, or IBM Cloud. So the big difference between RHOCP and Red Hat OpenShift Dedicated is that in Red Hat OpenShift Dedicated, you don't have to set up anything for yourself. You can just start using OpenShift. There are cloud provider managed OpenShift solutions. Look at the big cloud providers, and you will find different solutions being around there. Then there is Red Hat OpenShift Online, which is Red Hat managed OpenShift infrastructure that is shared across multiple customers. The idea in OpenShift is that OpenShift, of course, is just a platform that allows you to run containers and to make sure that you can run your containers. Red Hat OpenShift Online is providing just that. You don't have a dedicated infrastructure. You will share your infrastructure with multiple customers, which typically does not matter because OpenShift comes with security features that allow you to do perfect separation of your workloads and the workloads of other customers. Then there is Red Hat OpenShift Kubernetes Engine. That's a very interesting product, which is just Kubernetes and related features. You might be aware that in OpenShift there is some functionality that aims at the developer, CI/CD-alike functionality. That allows you to easily come from source code to running containers, like source to image, for example. Source to image and related functionality is amazing, but not everybody is using it. And now it happens to be that many people are buying OpenShift. They pay for the full package, which includes this developer functionality, but they don't use it, which means that you are wasting your money. And that is why there is Red Hat OpenShift Kubernetes Engine, which is just Kubernetes and the related features. So not including source to image and related stuff. Then there is Red Hat Code Ready Containers, which is a minimal OpenShift installation. And finally, there is OKD, the OpenShift Kubernetes Distribution, which is the OpenShift open source upstream. May I ask, who is using OKD already? I want to know if I have any experience here in class about OKD installation and setup, for example. Can you just say yes, no, please? Even if it's a no, then I do appreciate if you tell me no. Okay, that is almost... okay, couple of you anyway. Good. The cool thing about OKD, disclaimer, what is coming right now is the way I see it. You may disagree. If you do disagree, please do let me know. But OKD is supposed to be the OpenShift open source upstream. If you analyze the life cycle of OpenShift over the last couple of years, then you must have seen that OpenShift version 4 has been out for, I guess, about 3 years now. In the beginning, there was no OKD 4. There was only OKD 3, which is a very weird situation. Because in open source, normally software starts from the open source project, and based on the open source project and the participation of some companies in there, there will be commercial products downstream. In OpenShift, it seems to be the other way around. The way I see it, OpenShift seems to be an exclusively Red Hat related open source project. OpenShift is where Red Hat is making the money. It's the $34 billion product. OpenShift is the reason why IBM has purchased Red Hat at all. And developments are starting in OpenShift, and sometimes it results in OpenShift code ending up in OKD. I have a pretty pessimist view based on OKD. From what I see, OKD is not an open source upstream, it's an open source downstream. They're always trying to follow what is happening in OpenShift, and that is very complicated, which means that OKD is a hard to work with product. Just to state it the way I see it, I don't even consider OKD stable product. You shouldn't be using it, which is probably exactly the way they want it to be, because Red Hat wants to make money on OKD. Do realize that when I make statements like this, it is difficult to judge how exactly you should see that, because OKD as well as OpenShift can be used in different environments. I have spent my Christmas holiday on working on OKD clusters, on user-provided infrastructure. That is my own laptop, and in my own laptop, KVM virtual machines. And that was kind of a nightmare. But I'm also aware that if you are using OKD on infrastructure that is provided by a cloud provider where you can do automated provisioning, it seems to be a little bit better. But for the second solution, you easily need 64 gigabytes of RAM or much more, and yeah, that's what makes it a little bit complicated. I don't know if the guys who are using OKD already, what your experiences are. At any time, feel free to send me your experiences either by email or in chat. Let's continue and let's talk about the OpenShift components. So what are we going to talk about? Well, building blocks first. So in OpenShift, different components are integrated. To start with, in OpenShift 4.4 and later is, as I see it, no, not as I see it. If I remember it right, different components are running on top of a core OS. Core OS is the immutable operating system, which is used as the OpenShift foundation. The design idea of Core OS is that in Core OS you want to do a basic installation of your Core OS image. Once you've done your basic installation, you are not going to modify it anymore. It's just there. So Core OS is a foundation, the immutable operating system on top of which you run your OpenShift services. Then we have CRIO, which we should pronounce as CRIO, which is the OpenShift Containers Initiative or OCI compliant container runtime. And CRIO is used as a foundation to run containers. In previous versions of OpenShift, it was based on Docker. With the release of OpenShift 4, they have moved away from Docker. You probably are aware that Red Hat is not doing any Docker anymore. They have their Podman, and OpenShift is using the same solution. Then there is Kubernetes. Kubernetes is the open source orchestration platform, and that runs on top of the CoreOS CRIO layer. So in Kubernetes, you have different Kubernetes services that are going to be deployed sometimes as a systemd unit, sometimes as a pod. There is a web console for easy management. There is pre-installed application services such as an internal container image registry, monitoring framework, and much more. You will find them as operators. Operators are a big thing in OpenShift. And there are certified container images for programming languages, databases, and more. If you have already done source to image, in source to image, you are using these programming languages, container images. All right, Motion, thank you very much for your feedback. Seems as if I want to have a chat with you offline to discuss a little bit about your experiences in OKD. Right, OpenShift features. What kind of features are we talking about? Well, CoreOS, as I was mentioning, you have. Okay, but I think we are. Yeah, you are. I'm talking about CoreOS. What you say, Bart, is confusing me. You say CoreOS is end of life and replaced by Fedora CoreOS and Red Hat Enterprise Linux CoreOS. I consider Fedora CoreOS and Red Hat Enterprise CoreOS just the next stage in CoreOS, and that is indeed what I'm talking about. But let me prepare that link so that I can check later if there is anything that I need to investigate about it. Trying to copy what's happening here. My interface is doing weird. I try to copy, and now my interface seems to be hanging. That's not nice. Oh, it's back. I think it was me just doing something not right. Yeah, Bart, I will check. Bart, can you do me a favor and send me the link by email? That's easier for me to find it later. Anyone, if you have feedback and you think I should check some information on the internet, can you send links to that information by email? Then I don't have to be distracted from what we are doing here, trying to save the information that you are bringing me. Path is asking the difference between CoreOS and normal operating system. A normal operating system is a complete Linux installation. Complete Linux installations come with a lot of stuff that you don't really need if it's just supposed to be the foundation of an OpenShift environment. For example, on a complete Linux installation, you have services like a crond service, for instance, and many other services potentially. You have RPMs that need to be updated, and that's a lot of hassle. And that is part why there is a CoreOS. A CoreOS is an operating system that was designed in the same way as a container is designed. So you get a default package and you use the default package. On top of the default package, you are going to use your stuff. So CoreOS is minimal, and that means that in a CoreOS installation, if you are just going to try to install an RPM, change the configuration file, that is not going to work. I'm considering, by the way, to offer in the same way I'm offering this class, an OKD installation workshop, maybe sometime sooner or later. And that will be a nice location to explore what exactly is different in CoreOS. Let's continue and let's talk about high availability, load balancing, automatic scaling, logging and monitoring, and service and discovery, which are also features in OpenShift. If you don't mind, I don't want to spend too much time on the marketing stuff that you can find. This slide is more interesting, I think. OpenShift Features. OpenShift is providing storage. Storage is provided by the Kubernetes layer to offer access to many types of cloud, cluster, or local storage. The problem with storage in a containerized environment is that the storage is ephemeral or short-living, if you want. Which means that you can write to a container, but if you write in a container, you write in the writable layer of the container, and that's not really working well in a cloud environment. And for that reason, OpenShift provides access to external types of storage, like cloud storage, for instance. We will talk about storage later today. OpenShift is doing source to image. Source to image is one of the nicest features. It allows you to automatically build and run applications from source code. Can you say yes or no in the chat, please, to let me know if you have worked with source to image, if you have kind of conceptual notion what it is about? And okay, that's like 50-50. Thank you very much. So OpenShift is also providing an application catalog. The application catalog has many runtime languages that are used in S2I and can be extended by installing new operators. I will talk about operators separately later. OpenShift is doing cluster extensibility, which allows you to create new application resources. We are talking about Kubernetes custom resource definitions here. Custom resource definitions that allow you to add your own topics to the OpenShift cluster. And finally, OpenShift is offering operators. Operators have become very important in OpenShift 4. Operators basically are ready to run added functionality that makes working with OpenShift easier. They are applications ready to run applications, which you can easily run from the OpenShift environment. OpenShift operators are also what makes that OpenShift really needs lots of resources. Uh, if you are going to talk about the differences between OpenShift 3 and OpenShift 4, then you will see that the difference in terms of memory, CPU required resources are really huge, and that is because of operators. Operators are cool because operators make it very easy to add functionality to your OpenShift cluster, but at the same time, OpenShift operators make that you need to make huge investments in hardware in order to use it. All right, Motion is asking difference between S2I and BuildPack. I don't know. If anyone has any experience with BuildPack, please answer Motion's questions. I think it's okay, by the way, if somebody is asking question in chat and I don't know the answer, or maybe if I do know the answer, if you have an opinion about the answer to the question, please fill in. That's okay with me. Right, let's talk about cluster operators. So what are cluster operators? Well, these are applications that extend default Kubernetes functionality. And they typically are used to manage other applications. And they automate tasks such as deploy, update, backup that normally would be done by a human administrator. And operators are started from container images, and they use custom resources to store their settings and configuration. To storage, that is obviously a typo. Let me change that right now in the editable version of the slides. Custom resource definitions are used to define the operator. Didn't I already tell that? I think I just did. Custom resource definitions are something that comes from Kubernetes and which allows you to create anything as a resource in your cluster environment. In order to work with operators, there is an operator framework. So how does that work? Well, you can write operators in any programming language. There is no need for a specific SDK. The operator just has two requirements, and that's the ability to invoke REST APIs and use secrets to contain access credentials to the Kubernetes API. As we will move on in this class, you will notice that secrets really are a big thing in the working of OpenShift. And there's a framework, and that framework is a toolkit for building, testing, packaging operators, and that is providing stuff. Maybe I need to rush here a little bit because we are doing a lot of stuff in explaining what OpenShift is all about. Everybody, this is pre-release class, and in pre-release class it can happen that I suddenly realize, hey, we are wasting too much time on this. So do you mind if I hurry up the part about operators a little bit? Here's a summary. There's Operator Hub. Operator Hub is a web interface. It's used as an operator registry for publishing and accessing operators. These operators can be integrated in OpenShift, and if you do so, you easily add new functionality in OpenShift. And if you want to go see me through all the bullets on the slides, come back in the final version of the class, the recorded class that is. I am skipping the rest of here. What do we see here? OpenShift cluster operators. OpenShift cluster operators are more important because they provide OpenShift extension APIs and infrastructure services. This is something that we do need to know about. So these are operators that are an important part of the OpenShift package itself. First, there is the OAuth server. The OAuth server authenticates access to the control node and APIs. And that is what you are going to use, and we are going to do that later today or tomorrow. You are going to use OAuth to create user accounts and stuff. There's Core DNS, which works as an operator. Which is the OpenShift internal DNS server. There is a web console, which is the management interface, which runs as an operator. The internal image registry, which allows storing internal images, runs as an operator. And monitoring is also running as an operator. It generates metrics and alerts about cluster health. You can explore OpenShift operators as well. How are we going to do that? Well, let me show you my console. Is the font size readable, everybody? This is where I expect you to say yes or no. A little bit small. Well, if I make it bigger, then it becomes horrible if there's a lot of information. Most of you say yes, so I'll just keep it this way. So these operators run in specific environments in your OpenShift environment, and I would like to show you a little bit about that. First, CRC status. I will talk about CRC a little bit later on. As I was telling you, I expect you to have CRC running already. And I don't want to spend too much time talking about CRC itself. As you can see here, I have CRC operational. OC, who am I? Should be telling me that at this moment I'm kubeadmin. Kubeadmin is good for now. Kubeadmin is the administrator access to OpenShift, and in this administrative interface, we can do OpenShift cluster administration. That's exactly where I need to be. OC projects is telling us that we have these different projects. And what was the name? Again, we have the OpenShift -whatever projects. And these OpenShift -whatever projects, and as you can see, there's a lot of them, typically correspond to operators. In case you don't know what a project is, a reminder to self, I should realize that some of you have come in with Kubernetes knowledge, not OpenShift knowledge. The project is like a namespace in Kubernetes. It's an isolated environment. And in OpenShift, you will notice, especially for the system components of OpenShift, that OpenShift loves working with projects a lot to provide access to specific stuff. Right, this is maybe also a nice moment to type CRC console. That should be working out all right. Login with kubeadmin. No. Hang on, this is always confusing me. I've spent too much time on the command line. So back to the start screen. I'm doing it wrong. CRC console. There we go. HTTPS WD provider. There I should be able to work with kubeadmin and the. No. I'm messing up stuff. Help. Yes, motion. CRC console -- credentials is showing us that we can log in as kubeadmin. I want to go in as kubeadmin. There we go. And I want to use the password. And this is the password. And then, and this is where I'm always getting confused, motion. Everybody, I will explain this later in more detail when we talk about authentication. But this is a relatively fresh OpenShift cluster. I have not set any user accounts, so kubeadmin is what I should be using. So I am going to log in as Cube admin, and there I need the password. Oh, we paste and then we log in, and that is working. Okay, later we will learn how we can create our own user account, and that is where the HD password is coming in. I do like using the safe credentials in this environment. I wanted to show you the operators, and in the operators we have Operator Hub, and in Operator Hub you get access to all of these different operators, which can easily be added. So if, for example, you want to work with storage, you go to storage and you get access to your storage related operators. And what can you do from there? Well, you can work with local storage, for example, if that is the operator that you want to use. I do have a demo about that later. Installed operator is showing you that there's just package server, which is a part of the non-core operators that you will find in the OpenShift environment. Okay, what do we have next? Yeah, NTS, everybody, you know that this is a pre-release class, and I'm using it to debug some information as well. NTS are my note to self slides. If you see NTS, then that is something that you can ignore, but I'm going to use it when I am going to record this stuff. Let's talk about OpenShift architecture a little bit. So Kubernetes services are started as static pods. Static pods do not require access to the API service to start. Here we can see what it looks like. Instead of doing my drawings live, we can just talk about what we find in this drawing. So what is this? This is what an OpenShift node typically looks like. So it starts with Cryo, which is the container engine. On top of the container engine, we have Kubelet. And Cryo as well as Kubelet are started with systemd. So they are systemd units. And on top of the Cryo and Kubelet, you will find a couple of static pods. And these static pods include the core Kubernetes services. And these core Kubernetes services, that is etcd and Kube Scheduler and Kube Controller Manager and the Kube API server. If you have done CKA, then you probably know what a static pod is. A static pod is not something that comes from the etcd. It is a pod that is defined from a YAML file in the local configuration. And based on these static pods, the OpenShift processes are added. And these are processes like the OpenShift API server, the OpenShift Controller Manager, and Core DNS. And these are services that come from the etcd. Like OpenShift OAuth, and OpenShift OAuth is the authentication one. This is kind of a high-level overview of what the cluster looks like. Now, if you talk about the cluster itself, then what is typically involved? Well, a couple of components, and these components are an external load balancer, a control plane, and worker nodes. Everybody, we must make a difference between the real cluster and the cluster that we are using here. We are using code-ready containers, and in the code-ready containers, we have a one-node cluster. So everything is just running in one virtual machine. If you are going to build a real cluster, then there's an external load balancer. And the external load balancer is there because in a real cluster you have multiple control nodes, also known as the master nodes. These control nodes run the OpenShift core services, but as there is always a minimum of 3 control nodes, you cannot access the control nodes themselves. You need something in front of it to represent access to the services in OpenShift, and that's why you need a load balancer. So what do we have? Well, in a control plane, we have 3 nodes in high availability that run Kubernetes and OpenShift components. And then we have the worker nodes. And the worker nodes are used to run the user pods. Typically in OpenShift, there are constraints. Constraints are limitations that allow you to do or disallow you to do some stuff. And these constraints make that your end user workload should not be running on the control node. That's why we have worker nodes. Joseph is asking, that's enough CRC with only one worker to prepare for EX280? Yes, Joseph, it is. Before I even started this project, my big worry was, how am I going to tell people who want to attend this course to set up their own environment? But in everything that you will see on the exam, you will perfectly be able to do it in a one node only CRC environment. If you want to do EX280, you would need a full cluster. Well, that would make the installation very complicated, and that would basically mean that you can't go without Red Hat and Red Hat course environments if you want to do it for yourself. But in order to prepare for EX280, just CRC, the code-ready containers with one node is sufficient. Right, I am going to skip a little bit over the theoretical stuff here. Default storage, we'll talk about default storage later. I want to get to the part where we can get our hands dirty. So let's have a look at section 1.5, OpenShift installation methods. Yeah, let's go over this again. It repeats a little bit what we've already done, but it takes away a lot of confusion. If you start OpenShift, you don't really know what the possibilities are. You might be confused. So depending on how you are going to use OpenShift, you might not even have to install it. Everybody, we are doing EX280 here. EX280 is an administration class. In an administration class, installation and working with real clusters is the purpose. So anything managed is not really useful in EX280 environment. But people who are using OpenShift might be using OpenShift without any needs to install it. How does that work? Well, there's Red Hat OpenShift Dedicated, which is running in cloud and is managed and installed by Red Hat. There's Red Hat OpenShift Container Platform, which can be installed on-premise. There is Red Hat OpenShift Online, which is managed and installed in cloud. There's OKD, which can be installed on-premise, but also in cloud. And there's code-ready containers, which provides the minimal installation that you can run on your own laptop. So, generically speaking, we have no less than 5 different ways of using OpenShift. The important thing to realize here is the difference between OpenShift in your own hardware or virtual machines and OpenShift in a managed environment. We don't care about the OpenShift managed environments. We only care about the OpenShift in your own environment. Right, the installation methods. There is full stack automation. Full stack automation is a method that requires minimum installation data to set up fully functional OpenShift cluster on pre-installed cloud or virtualization provider. The nice thing about full stack automation is that full stack automation is going to talk to your hypervisor, for example. You can do it on VMware vSphere. Full stack automation talks to vSphere and makes sure that all the nodes that you need are going to be created. That's cool, but not what everybody is doing when they do their installation. The other installation is pre-existing infrastructure, and pre-existing infrastructure requires you to configure, set up computer storage and network resources, and that is what you want to do to build your own OpenShift environment. If you are going to do that, then control planes are used to run RHEL CoreOS, and worker nodes may run Red Hat Enterprise Linux. But RHEL CoreOS or Fedora CoreOS, if you go for the OKD direction, is what you should be prepared for. This is about the deployment process. I'm going to skip that one. I want to get to the part where we can get started with OpenShift as fast as possible. So the code-ready containers-based installation. What is code-ready containers? Well, code-ready containers is what you can find on developers.redhat.com, and it's an all-in-one Red Hat licensed version of OpenShift 4. Nice thing about code-ready containers is it works on Mac, Windows, and Linux. And even if it works on Mac, Windows, and Linux, I would recommend you try to use a dedicated Linux virtual machine to avoid any conflicts. Why am I saying that? Well, if you are going to run code-ready containers in your own virtual machine, then it's not going to interfere with anything else that you are doing on your hardware. If you run it on top of your macOS operating system, and after that you want to work with Docker on the same macOS operating system, that's going to bite one another. So make sure you think about that. So code-ready containers just have a little bit of system requirements. The system requirements are really not much, considering what you normally need for an OpenShift environment. Just 4 CPUs, 16 gigabytes of RAM, and 35 gigabytes of storage in /home. Don't try to run it with 8 gigabytes of RAM because you will run out of RAM. 12 gigabytes of RAM will do. Hey everybody, can you let me know in the chat how you are using code-ready containers? What is the operating system that you are using it on? Is that a virtual machine or is that on top of something else? Okay, lots of virtual machines. That's good. Nice, lots of different configurations. I don't know if it's a cool story, but I'm going to share it anyway with you. I had prepared a very nice 64 gigabyte machine, and this 64 gigabyte machine was running Fedora, and on that machine I had code-ready containers, and everything was working smoothly. I had code-ready containers in a virtual machine, by the way, and then I started working with my OKD cluster, and in order to get through the OKD cluster, I wanted to change my DNS to use core DNS instead of bind DNS. So I reconfigured my client to use core DNS instead of bind DNS, and suddenly my code-ready containers stopped working. So what do I want to say with that? Well, be very careful. If you are going to use core DNS with everything else that you are going to use, if you are going to use code-ready containers with everything else that you are going to do on your hardware. Because changes, even at unexpected levels, but especially changes in the networking layer, might negatively impact what you are doing in your CRC environment. Okay, apart from that, OKD4 can be installed as well, but it requires a recommended minimum, lots of RAM, at least 20 gigabytes, much more depending on how you want to do it. To the question who asked, can we run where was it? There was a question that I did not answer yet. Part is asking, MacBook Pro 2020 with 8 gigabyte of RAM is fine? No, absolutely not. You cannot run core DNS code-ready containers on 8 gigabytes of RAM. At least 12 gigabytes. And Nazar is mentioning you can go ahead with CRC cleanup. That is not entirely true, Nazar. CRC cleanup is removing some parts of the configuration, but when you are using code-ready containers, Then it creates a CRC directory as well, and in that CRC directory there is the machines subdirectory, and somewhere in there is your image, and that is not something that that it's going to clean up for you. It can bring you agony. That's the message that I want to pass you. And even if the documentation says, yeah, you can run your code-ready containers easily, you can clean it up easily, there are parts that you need to consider as well. So yeah, Ricardo is mentioning hardware specs are confusing. That is right. In the hardware specs, and that's why I'm putting on the slide, just make sure you have 16 gigs of RAM, not 8. Because Ricardo is mentioning if you have less than 9.7, the installation will abort. That's absolutely right. The minimum what you need is 12 gigabytes of RAM. If you go below 12 gigabytes of RAM, it just won't work. That's why on the slide I've put 16 gigabytes of RAM. If you're tight on RAM, 12 gigabytes should do as well, but don't go lower than 12 gigabytes. And if you are low on RAM, like a 16 gigabyte laptop, for example, then I would say try to avoid including a virtual machine layer as well. Just run it directly on top of your operating system. All right, let's continue. Let's talk CRC on Linux. And let me also check. Yeah, we are almost at the end of this lesson 1. So let me finish this, then we do a break, and after the break we will continue with lesson 2. Funny thing, do I still agree with what I say here? Yeah, this is about CRC on Linux. So how does it work? Well, you use CRC setup as a non-root user, which will provide initial setup. Then you can use CRC start -p pool secret -m 12244, which will create a CRC virtual machine with 12 gigabyte of RAM. The -p pool secret. The pool secret is credentials that you need in order to get components from K. K is the image registry that is very important for installing anything OpenShift. And in order to get access to the components that you need to work with OpenShift, you need a pool secret. And you can get the pool secret on the developers.redhat.com website, same location where you download code-ready containers. We have already seen CRC console. There is CRC console credentials, CRC OCN, which will provide information about the command that you should execute to add the OC binary to your path, and then you can use OC login to log in to your cluster. Back to the cluster, OC, who am I? This has already been set up a little bit, is giving that I'm currently logged in as admin, and OC get all, always a useful command as well, should give you access to OpenShift components that currently are running. I've been playing a little bit with this system, so what you see here is not a brand new installation. Some more OpenShift considerations. Well, this is basically repeating what we've just seen. Maybe a nice one is OC get CO. OC get CO. CO is showing the operators that come by default with your OpenShift environment, where you can see all the operators with their current state, and you can see if they're in degraded state or whatever. Useful for troubleshooting. For some reason, it doesn't work out well. This is also a nice one. How do we get access to CRC? CRC is a virtual machine, right? So if you type ls on tilde for home directory .crc slash machines CRC, and that's a good tip. Bart, can you drop me that in an email, please? because that's something that I like so much that I even want to include it in my slides. So right here we are in .crc machines crc, where you can find that there's an id underscore rsa.pub, and using this id underscore rsa.pub you can use ssh minus I on, now I need to type the entire path again, crc machines crc id underscore rsa dot pub, and then I can log in using the core user account at crc ip. What? Why do I get permission denied? That's not supposed to be happening. Oh, load key id rsa pub is invalid format. That is interesting. Oh yeah, I use the public keys. You are right. Thank you very much, Nazar. There we go. Here I am on my CRC machine. And this is the Core OS machine. Let's explore it a little bit. So cat on etc OS release is telling us this is Red Hat Linux Core OS. And this Red Hat Linux Core OS currently is running a little bit over 8 gigabytes of RAM, where you can see that it really needs it, even if it still has 3 gigabytes available. If we use top, for instance, then we can see the different processes that are running. And if you use other commands, what else is interesting? df-h, for instance, is showing the different file systems that are available, where we can see right here the dev mapper CoreOS Lux root no crypt. This is the Lux file system that is used as root. And if you type rpm minus qa, for instance, you can see the RPMs. But if you type sudo dnf install nmap, for instance, then you get dnf not found. Oh no, doesn't have DNF. Should we use yum? No, you shouldn't use yum. You are in a CoreOS environment. And in a CoreOS environment, it does not work like a regular operating system environment. So if, for example, you use sudo vim etc hosts because you want to configure your etc hosts, then, well, just don't do it, because this is CoreOS, and CoreOS is not meant to be used as an ordinary Linux machine. I think this is enough about the CoreOS so far. We will have one instance where we need to get into the CoreOS machine later, but that will come later, and I think now is a nice moment to go for our first break. Everybody, this is how it works. I like using break timers, and I like using 12-minute breaks. So in order to do that, I am going to start my break timer. It's a shell script. Some of you might know it. Oh, is that so? You know what? Let me do it differently. I have a timer in this interface as well. I am going to set the timer to 12 minutes. During the break, I will go on mute, make myself some coffee, and I will see you after 12 minutes again. Hello again, everybody. I am back, and it's time to continue. Can you please confirm that you can hear me in the chat? That is good to know. Right. I discovered this very nice feature here. It allows you to see if you are focused in my screen or doing something else. Ha, that's awesome. Let's continue. I've been considering a little bit what we are going to do. You know, one of the reasons for doing pre-release courses so that I can test content for myself. And I think we should skip lesson 2 and go to lesson 3. For the simple reason that lesson 2 is a demo on the web console, and it's not the most important thing. Lesson 3 is very important. And lesson 3 is about working with resources in OpenShift. Let me use the PDF version. There we go. You should be seeing my screen, and in the screen, PDF with lesson 3, managing OpenShift resources, with the title, working with projects. In this lesson, I'm going to use my drawing tablet. So give me a few seconds to reorganize my desk so that I can make my drawing. All right. Tablet is starting up, so I should be able to make drawings less, and that's also just interesting for me. Yeah, I'm ready. You know this warning. Just make sure that the warning is inside every single slide set that I'm distributing. And in case you came in late and have not yet checked the QR here, please do so. So we are going to talk about managing resources in OpenShift. If you are relatively weak on the basics of OpenShift and stuff, this is probably the most important lesson for you, because here we are going to visit some of these fundamentals again. So the starting position is the project. The Linux kernel is providing namespaces. These namespaces offer strict isolation between processes. That's something that's happening at the kernel level. Kubernetes is using that kernel level feature to implement namespaces in a cluster environment as well. And because of namespaces, you can create isolated environments in which you can completely limit the possibility to get from one namespace to another namespace. Namespaces are very important, very essential for traffic limitation, but also because you can apply resource limitations on namespaces. Working with resource limitations and limits is an important part of your EX280 exam. And you can also use them to delegate management tasks to users. We will talk about users, and I'm going to make sure that we can talk about users later today instead of tomorrow. So tomorrow we have sufficient time for these complicated tasks. But once you have created your users, you can grant these users access permissions to a specific namespace. OpenShift implements Kubernetes namespaces as a vehicle to manage access to resources for users. And in OpenShift, we have an addition to the namespace. Namespaces are reserved for cluster level admin access, and users work with projects to store their resources. So what is the difference? Well, the difference is that an administrator level user will see all of the namespaces, and an administrator level user will see that there's no difference between the namespaces in the OpenShift projects. If you become an ordinary user, then projects become important because that is what you can see. And system namespaces are hidden from ordinary users. Now here we have an Nts Demo, which means that I should show you something, right? In case you missed it earlier, if it starts with NTS, then it's a note to self. And in this class, I've not really removed the notes to self. I'm in the demo environment now, where you can see that OC Who Am I is showing me that I am the Cube admin user. I'm going to use OC Get Projects. And OC Get Projects is giving a list of all the projects currently existing. Pipe WC, you can see 60 projects in total. And if I type OC Get NS for namespace WC, we can see that 60 namespaces in total. That's just to show you that there's not really a difference between projects and namespaces. But I'm administrator now, so let me use OC login -u developer -p developer. If you are in code-ready containers, developer is your default account. And there you can see that this developer has one project on this server, which is limits. So OC project limits, and that's it. OC get projects is showing just this one single project, and OC get NS is saying forbidden, namespaces is forbidden, use of blah blah, cannot blah 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 blah. Then it's RBAC, role-based access control. We will talk about role-based access control later today, maybe, and if not, tomorrow. Now, if you are an ordinary user, then the project is your base environment. I'm going to use OC new project to create a new project. Let's call it my project. And there you go. We have a new project. And now if I type OC get project, you can see it works with and without the S. We can see all of these projects that exist. And now let's get back to the admin environment. I like using Control-R, Linux history, the reverse lookup in bash history to easily get back to my admin shell. And you can see that admin still has access to 60 projects, so that did not change at all. These projects are important for working with OpenShift. These projects are also important for your EX280 exam. Red Hat likes it very much if the different tasks that you are using are going to be done in different projects. Hey, I have another question now that I'm talking about exams. Can you tell me in chat, please, if you are CKAD or CKA or not certified at all? I would also be interested in knowing if you are EX180. Oh, Motion, you are already CKS. That's great. Okay. Yeah, I just wanted to know if I'm talking about any type of certification, if that makes sense, or if I need to tell you a little bit more about that. Cool. Let me continue and let me do that on the slides. So what we're going to do now, we're going to talk about applications. In OpenShift, we have this command, OC new app, and this command can be used to create an application. And an application in OpenShift is like in Kubernetes. If you create an application, you will create different Kubernetes resources. And that is what I would like to tell you about right now. I'm already preparing my drawing interface. Am I right in assuming that you cannot see the drawing interface? Is that so? So say no for no drawing. Yes, the question was difficult. Yes, we cannot see. Okay, good. Then I need to do something on my screen sharing to show you the drawing interface. I expect you to see the drawing interface at this point. Is that right? Yes, that is right. That's good. I want to talk about basic Kubernetes resources. So if we talk about Kubernetes, we have the API. The API, what's happening to my pen? Pen is dead. That's not cool. Hang on, let me reset. I love using my drawing interface. You probably can't see anything at this point. I'm working on that. Because if I don't have a pen, I can't draw for you. And that will be too annoying. Now it's working. And now you should be able to see it again. Good. This is a little Kubernetes / OpenShift resources 101. So what is it all about? Well, it's all about running containers, okay? So in OpenShift is about managing containers, but OpenShift does not manage containers. OpenShift manages pods, and the pod contains containers. You don't see it, okay? That is surprising because my software is telling me that you can see it. Let me switch again. Can you see it right now? You cannot. That is interesting. How about now? Now you can. Okay, good. You see white canvas. I'm just thinking if I have two windows open. So here we go. Did anything change? Okay. Different approach. I'll be right back. I am just wondering what's happening here. I've changed to sharing my entire screen. The drawing tablet is working as an external screen, and I'm just wondering if at this point you can see the drawing or you can see the terminal. Or can you see terminal only? Okay. That is too disappointing. And did this change anything? You see hello. Good. You can see hello. Final test. And now you see bye. Okay, good. And then let me use something a little bit more readable. There we go. And let's try again. Just final confirmation. You can see a square right now. Is that correct? Good. Then we are okay, and I can make my drawing. I wanted to talk about the pod. Pod is a minimal entity of what is managed in a Kubernetes environment. And in a pod, the pod is the thing that manages containers. So CONT, that's short for container. You get that. In a pod, you can also have volumes, by the way. This is the minimum that Kubernetes is using. So Kubernetes does not manage individual containers. Kubernetes manages pods, and these pods have different properties that make that you can easily work with these pods in a clustered environment. But in Kubernetes, you don't manage pods. In Kubernetes or in OpenShift, you would use commands like OC new app. And if you use OC new app, then you get a new application. And this new application is created as a deployment. Now, here is where it's starting to be a little bit confusing, because instead of deployment, you will also hear about deployment config. Now, which one is it? Well, the thing in OpenShift is that OpenShift is using two different APIs. There's a Kubernetes API, there's the OpenShift API. If you go ask the OpenShift API is working with deployment configs. If you go ask Kubernetes API, the Kubernetes API is working with deployments. And to make it even worse, if you know a little bit about the history between OpenShift and Kubernetes, then you might know that OpenShift is sometimes using older Kubernetes API resources. Help, what is this all about? Well, I think this is all about that you know that an application is known as a deployment, and a deployment is more or less the same as a deployment config. I'm saying more or less, okay? Not completely the same. And this deployment config or deployment is adding specific properties that make managing in the application in a clustered environment doable. One of the things that is included in the deployment or deployment config is the replica set or the replication controller. Same story here. Replica set is Kubernetes terminology. Replication controller is OpenShift terminology. And they are interchangeable. So if you're in OpenShift, you want to work with deployments and replica set, that is okay. If you're in OpenShift, you want to work with deployment configs and replication controllers, that is okay as well. You do your OC new app, you get your deployment and your replica set. The replica set is taking care of a replication, and the replica set, we will talk about that later, is managing the number of replicas in your application in total. Now, there is something else that is involved, and I did not really leave space in my drawing on the top, so it's ugly, but I'm going to draw it on the bottom. There is also a service. What is a service about? The service is a Kubernetes object, and this Kubernetes, I should say resource, by the way, this Kubernetes resource is really working like a load balancer. A load balancer that provides access to the different instances of the pods that are running in your cluster. Now, if you would talk Kubernetes, then the next question is, hey, if we have a load balancer, we need to provide access to that load balancer to the external world. In Kubernetes, you would use ingress in order to do that. In OpenShift, we have routes. And the route really is a URL, to say it in a simple way. We will talk about routes in much more detail later. For that reason, I'm permitting myself to keep it simple right now. Now, when you are going to use OC new app to create a new application, then what exactly is going to happen? Well, you are going to create all of this in your environment. And these different resources all have their properties, and these properties make that you can manage them in a clustered environment. This is basically your Kubernetes 101. And hey, if you need to fill in on your Kubernetes basics and you happen to be on the O'Reilly platform, I'm teaching Kubernetes in 4 hours on Thursday if you need more details about Kubernetes. The thing that you should realize at this moment is that if you run an application, you get all this kind of stuff. And all this kind of stuff together makes that you have something that is working in your cluster. Right, there was a lot of effort to give you the drawing application, but now I'm getting out of the drawing application again. I want to go back to my screen. Hey, I found something new. Show my. Did you see that? Main screen. Now you just quick test. Can you let me know if it works? Now you see my terminal. Now you see my drawing application. Is that right? And now you see both of them. Cool. I just discovered something in this interface that will make it a lot easier next time I'm going to share anything. Yeah, magic. No, not really. Back to slides. So what is this slide saying? Oh yeah, this slide is about OC new app. So if we create a project using OC new app, we get this deployment, this replication controller pod route. One other resource in OpenShift is source to image. Source to image is what is building your source code from your Git repository straight into a running container. If you are going to use source to image, additional resources are used as well. We will find that later. What do we have next? Even if I hate follow along with the slides, I am going to follow along with the slides anyway, because I need to test and make sure that this is working, okay? That's the purpose of the pre-release. So understanding resources, what do we see here? Well, we see that different Kubernetes resources are used. Each resource is defined in the API to offer specific functionality. The API defines how resources connect to each other, and many resources are used to define how a component is running in the cluster. It's basically what we've just seen in the drawing. And yes, the resources are defined in the API. If you ever want to figure out which resources are available in the API, try OC API resources. Oh, typo. I was wondering why is it complaining, but here we can see the OC API resources. Let me pipe that through less because it helps if we understand just a little bit. We have the different resources like pods, for example, like nodes, for example, for the nodes in your cluster. Some resources have a short name. Then we have the API group. If you see nothing in API group, it's the core Kubernetes API. We have namespace, true or false, which is to indicate if a resource is to be bound by the boundaries of namespaces. And we have the kind, which is the camel case name of the resource. Sometimes you need camel case, sometimes you don't. Interesting is that in here you can see other APIs are being used as well, like apps, for example. Apps is one of the most important API additions to the Kubernetes API. And point taken motion. I'll do that in a little bit. If you go a little bit further, then you can see that apart from the Kubernetes APIs, there are APIs that have OpenShift in name as well. So very frequently, especially in OpenShift beginner classes, people are asking me, hey, what exactly is the difference between OpenShift and Kubernetes? Well, the easy answer is that OpenShift is just a Kubernetes distribution. The more complicated answer is that OpenShift is adding APIs to enhance Kubernetes functionality. And these enhancements all show in these OpenShift API types. APIs can have different origins, like here, for example, monitoring.coreos.com. Apparently, that's coming from CoreOS. And the more operators you put in your OpenShift cluster environment, the more APIs you will see if you type OC API resources. Motion, you have a very good question. Motion is saying it would be great if you can enable OC command completion. Now I regret that I'm on macOS. But I type OC completion -H. What do we see? We see installing bash completion on Linux. We see also installing bash completion on macOS using Homebrew. I think I need the macOS approach. I'm in Mac bash shell. I don't like ZSH. Which is why I am in bash on Mac, and I probably need Homebrew version 2. And then I need to run this command. If you're on a Linux bash shell, it's so much easier. In case you are wondering, by the way, what is Sander doing on a Mac shell? Well, that is easy. I messed up my Fedora laptop and I couldn't get code-ready containers to work on my Fedora laptop anymore. Chopay is asking why I don't like ZSH, because it changes everything. And I am very well aware that working in IT is all about working with changes, but I don't think shell is important enough to dedicate my time to investigate changes between bash and ZSH. You know, I can do things eyes closed in a bash environment, so I really hate it that suddenly we have a different shell. I also hate it that it seems to be kind of stuck here. Oh, make install, that is why. It's compiling stuff. So if anyone else has an off-topic question, now is the moment to ask. And there we go. So now I need to type OC completion -H again, where it is. Thank you very much about it. That is why I regret a little bit that I'm on macOS here. Bart is showing you guys how you can do it on Fedora. It looks as if brew install bash completion @2 is giving the right thing. OC tab tab, it is not. So probably I also need to do my OC completion command. And OC tab tab, well, folks, beats me. I will give this no more than 2 additional minutes. Yeah, I need to run a new bash. Yeah. Oh. Do I still have my history? That is good. Am I still somebody? OC, who am I? I am still Cube admin. And OC tab. Guys, this is a nice one to investigate further during the break. I don't think this is important enough to spend a lot of time on. I think there's more important things to talk about. To be continued. Let's do a little demo with these resources. So I am going to use OC new app, Rails, Postgres, QL minus example. No, I don't want to do that. Let's put a comment behind it. Let's do OC new app minus H. Just to show you that the OC command, which is a lot like the kubectl command, but not completely, the OC command is providing nice additional information about stuff that you can do. If you type OC followed by the subcommand, followed by anything that you would like to do, then you add minus H, and minus H will show you usage examples. And apart from the usage examples, it will show you command line options. And if you know how to use the minus H option, you will get pretty far. OC minus H is showing just the commands that you can type behind the OC command, and OC subcommand minus H will show you how to use that. Now let me run this OC new app Rails Postgres example. This is just some example application. Notice that I'm not using any name or image option. If you use a command in the way I'm using it right here, it is going to check and see if it can find an image with the name Rails Postgres example, and it will run the Rails Postgres example application. Then when we type OC status, it's giving information about current process, and in this information we can see that it has a service SVC Postgres QL. It has a DC, so that's the deployment config, deploys OpenShift Postgres QL. And it is even giving a URL, and it's showing hierarchy about what is happening in the OpenShift environment. And if you type OC get all is showing you an overview of all these different resources that has created. And oh wow, did you see that? What do we have here? Well, a lot. Let's start at the top. At the top we have route. The route is providing a URL, and this URL is what you are going to use to access your application. The route connects to a service, and the service, we can see that right here in the name of the route. The service is a Rails Postgres example. So right here we can see Rails Postgres example. The service itself connects to deployment config, and the deployment config must be deployment config.apps.openshift.io. The deployment config on its turn connects to a replication controller, and the replication controller connects to some PostgreSQL pods. And we can see in some cases a readiness indicator of 0 out of 1, which means that the thing is still building. Now, the other thing that we can see here, and that's quite interesting as well, is that there is a build config, there's a build, there is an image stream. And that means that this specific Rails Postgres example application is an application that is defined in a way that it will get its source code from a Git repository, and it starts building immediately. That is why you see the image stream, you see the build, and you see the build config. Now, if you want to know more about these image streams, OC get image stream. What is this OC get image stream? This OC get image stream is giving you information is giving you interpreters. It's a better way that can be used while doing source to image. But hey, I'm just realizing that maybe I'm going a little bit fast on source to image. So let me show you drawing. Just checking. You should see my drawing at this point. If you don't, then let me know. And yeah, it's nice if you do that you let me know as well. Thank you, Nazar. Okay. This drawing is about S2I. S2I is source to image. So what is source to image? Well, source to image is about the application build process, which typically starts at GitHub. I call it GitHub. I should say Git. I know, because GitHub is just one way of doing Git. So in Git, you have your my repo or whatever. And in your my repo, you have source code. Now, the complicated thing about source code is that your source code can be written in a wide range of different languages. And OpenShift wants to automatically make it possible to automatically build your source code. But if it wants to automatically build your source code, then we need knowledge about these different languages. That is where the image stream is coming in. So what is the image stream? The image stream is the language interpreter for your source code. So based on the image stream, source to image can do its work, and it can generate a builder image. And this builder image is really compiling your stuff into a build. And once your build is there, it will create an image. And that is where you want to be, because in a Kubernetes environment, so also in an OpenShift environment, you are going to run containers based on specific images. So what is happening in source to image? Well, source to image is converting your source code into a runnable image. And this runnable image is next going to be used in a pod, and this pod is a part of a deployment, and this deployment will be made accessible through a service, and this service will be exposed using a route. So all the way down the road, while we were using our OC new app command, we have seen all of this occurring. Okay, so it starts with the source code, the image stream is involved, the builder image is involved, results in a build, results in an image, results in a running application. That is one of the nice things about the OC new app command, because the OC new app command will create everything for you. Right, that is what I wanted to share based on what we have just seen in this OC get all command. And yeah, I'm just trying to do something cool. At this point, at the left side, you should see my first screen, and on the right side, you should still see the drawing, including the image stream and the build config, and also the pods that have resulted in all of this. Notice that in the pods, you can see a pod with the name build, which is completed. That's a pod that was used to build the actual application. Can you say yes, no, to let me know if you've worked with source to image, please? Just in chat. Also a nice way to see how many people are still actively participating. So yes, no, to let me know if you've worked with source to image. And thank you very much for your feedback. It's about 50%. Okay, thank you very much. We'll get back to source to image, but this is roughly giving you an impression of what it is doing. And image pool backup, but you are probably referring to something that's going wrong in my configuration. Is that so? OC get all. Because if that is so, then we have some troubleshooting to do, but I'm not going to do that now. This is not the moment to get there. For those of you who want to learn more about source to image and stuff, that is going to be in my EX280 class. That's the one that I'm going to fix later after releasing this one. I was talking about it, been thinking about it a lot. It makes so much more sense to first record an EX180 class and only after that doing an EX280. But I wanted to make sure that EX280 is working before wasting my time on yet another basic class about OpenShift and related stuff. Right, let's have a look at what is next. So I demonstrated this stuff, monitoring applications. What can we do in the context of monitoring applications? We can figure out what is happening in an application. Just thinking about how I am going to present that. Yeah, let's talk about monitoring an application, because sometimes you run your application, and ultimately, if you run an application, you want pods. Okay, so let's focus on the pods. I will skip everything else. I will focus on the pods for the simple reason that the pod is your complete and running environment. I mean, if you're going to work with OpenShift, don't get confused with all these different resource types. Remember one thing, in the end, you want to run your application. Your application is a binary. This binary will be started from a container. And in order to start your binary from a container, you need pods. So if you want to see whether or not your application is successful, my advice is to focus on the pod, because the pod is a representation of the running process. And in order to figure out what is happening in these pods, you can do a couple of things. Thing number one is OC logs. So what is OC logs? And yeah, my tab completion still doesn't work, so I'm going to use the mouse. OC logs is going to connect to the standard output of your application. The thing is, you run your application in a pod. An application normally wants to be able to generate output. This output normally is sent to the screen. In OpenShift, you run containers. Containers are not directly attached to any screen. So if you want to know what's happening in your application, you type OC logs on your application. And that is showing you the application output. Now, let me do something else. OC, what do I want to do? I want OC create deployment. My MySQL. It's a weird name, but what do we care? -- image is my SQL. It's going to create a deployment, okay? The difference, OC new app is a more OpenShift kind of way of running your applications. OC create is a more Kubernetes way of running your applications. The advantage of OC create is that you don't get that many resources. That's why I kind of like OC create, because OC create will create a deployment. It will create a replica set, and it will create a pod. And oh boy, what do we see? Pod MySQL is in crash loopback off. If you have a pod that is in crash loopback off, that means that your primary application could not be started. So we need to figure out something to start it anyway. And what are we going to do? Well, we are going to copy the name of the pod, and we are going to use OC logs on the application output. And there we go. Here is the application output. And what is the application telling me? It's telling me, hey, dude, database is uninitialized password, blah, blah. You need to specify one of the following. I like this example because this example is asking MySQL, and MySQL is telling us this is going wrong because I am missing vital information. I'm not going to fix and troubleshoot it right now because it's not about getting a MySQL that's up and running. It's about understanding the flow of analyzing what your application is doing. Another way of having a look at your application is OC Describe. What is OC Describe doing? OC Describe will tell you from a Kubernetes point of view what is happening. So if I use OC Describe pod MySQL whatever, then I'm going into the etcd database. The etcd database is the heart of Kubernetes, and in this etcd database, it will show me the flow of events that have happened when the Kubernetes cluster was trying to create this application. Especially these events are important. Where we can see that it successfully pulled an image and it created a container, and then, oh no, back off, restarting failed container. And if you see anything like that, you might want to scroll up a little bit to find the section containers where we can see the state. In this case, state is terminated, where we can see the reason error. That's not providing a lot of information, but if you see a reason error, then it means that the primary application in the container generated an error. And that is why we get a reason error. So reason error right here is basically telling us, hey, you need to use OC logs to see what the application is generating as error output. If you really are into lots of details, on a running container, you need a running container in order to do that. Then you can, no, sorry, you don't need a running container. I was mixed up with something else I was thinking about. You can also use OC get on a pod -o YAML. Oh, and if you do that without typos, then you get the YAML code that's been generated. And this YAML code is giving you status information. And this status information is the role information that was created by the cluster. I think this is what you need to know about monitoring, about analyzing why your application has been successful or not at all. With that, we are almost at the end of this third lesson, but I think we need a break. After the break, we are going to talk about exploring API information. After exploring API information, we'll do storage. So we will do storage and we will do authentication still today. And we might even be doing RBAC, and then we will see where we get tomorrow. Anyone, any questions so far? Are you still here? Everything clear? Good to hear that at least you are still here. So far, so good. Okay. Nazar is asking, will the recording be available? Nazar, let me put it this way. To be honest, I have a few doubts about providing a recording, but let me put it this way. If you take the effort of being in this class, then I think I should make the effort of providing the recording for you. So I am going to make a recording, but I will have a look at the attendance report. I don't want to provide recordings to people who don't make the effort. So you're all here, and that's great. But maybe some of you will leave, and I won't hear of you anymore. And hey, part of the deal was that I am going to get your feedback, and in return, you get my information. If you are here If you are participating, then I have no trouble providing the recording at all. I am human. If you need to leave early for whatever reason, send me a message and I will still provide the recording. But I just want to avoid that people are signing up, not doing anything in class, and then get the recording with the risk of the recording going to live its own life on the internet. I hope you understand my point of view, but as long as you are here participating and we have good atmosphere together, then yeah, we will do. I will make a recording. Isaac is asking, what about exercises? Isaac, I do have a couple of labs, but so far I don't have anything interesting yet to do a lab. But hey, Isaac, if you want to do something useful during the next break, then I would say lesson 3 lab. It's in the slides. That is what you can use as an exercise. I am not going to allocate too much time on exercise. I mean, if you want something to play with, use the labs as far as they are available in the end of the lessons. I'm not going to review the exercises until we have covered all topics in class. Because some of the topics that we are doing tomorrow are a little bit more complicated, and I want to make sure that we don't run out of time. But if you want to play, this is something that you can do. I hope all of this makes sense. Parth is asking, after pre-release class, any ETA for full-fledged course for EX280? Parth, here is my timeline. My timeline is that I am going to finalize the slides this Wednesday. Then after the weekend, I will have my first set of slides back and I can start the recording. After the weekend, then we are January 11th. That means that the recording should be finished January 25th. Production needs 3 months, and that means that end of April, we will have the final product available. End of April, that is. Also in April, I want to offer this class as a live class on O'Reilly training. Of course, that only makes sense if you are on O'Reilly training. But yeah, end of April, the course should be available. We are facing a production time of 3 months, and there's nothing I can do about it. Abal Fazi is asking, is it okay to send question in mail to know beyond EX280? Yeah, I think it is. Please do consider that sometimes I'm drowning in email messages. So don't make your questions too complicated to increase the chance that you get a useful answer. And with that, I think we should have our break. So I am going to start the break timer again. And this time I won't forget pressing the start button. 12 minutes. We'll do 12 minutes now, and our next break, then we have worked for 3 hours. We'll do a little bit longer. If you need to go grab a sandwich or whatever, you have a little bit more time. But now 12 minutes. I will mute myself. I will see you in 12 minutes, which is 28 past the hour. See you in a bit. Hello, everyone. I am back. I hope you are back as well. I do appreciate if you can let me know. Thank you, Chokai. And thank you, other folks, for confirming that you are here. Good, nice to see that you are actively here. I'm so used to teaching classes on the O'Reilly platform, where sometimes I'm talking to 300 zombies at the same time, but here I'm actually working with people. That's awesome. Right, I would like to talk about API and a little bit more about API. We have seen that OpenShift is based on Kubernetes API. Hang on, I need to check and see that we're still recording. Yeah, we're still recording. Good. So OpenShift is based on Kubernetes API. And we have seen the command OC API resources. which is listing all the APIs and the resources that are defined in the APIs. Apart from the Kubernetes API, OpenShift is adding specific own APIs. And that is done to add resources that just don't exist in Kubernetes. And in some cases, to offer alternative resources, alternative to the resources as they exist in the Kubernetes environment. So, because of these different APIs, OpenShift resources are not always guaranteed to be fully compatible with Kubernetes resources. But if you use your OC API resources the right way, then you should be cool. Now, a very important skill is the skill where you can explore what is available in these different APIs. Let's demo. We have already seen OC API resources, right? This is the list of resources in the API that it is coming from. But very important, if we do OC API resources pipe grep -i deploy, then we can see that there is deployments. Deployments comes from the Kubernetes apps API. And there is deployment configs. And deployment configs comes from the apps.openshift.io API. Now, if we want to explore the differences, then we can use OC Explain. I will first show you generically a little bit about OC Explain, so that you understand what it's about. And then we will specifically analyze and see if there are significant differences between deployments and deployment configs. So OC Explain on deployments is showing us what? Well, it's showing us the type of information that we need to use, that we need to specify if we are going to directly address the API. So we can see it as API version, as kind, as metadata, as spec. This type of information is information that you can use in YAML files, because you should all know that YAML files is what you ultimately want to work with, right? So if we have mypod.yaml, for example, if we have mypod.yaml, for example, then you can see API version in kind and metadata and spec. But we'll talk about mypod later. We should talk about OC Explain at the moment. So OC Explain deployments is showing the four main components, and these are components that you will always need to define if you are going to write your own YAML files. So we have API version. API version is identifying the version of the API that you are going to use. We have kind, which is identifying the specific resource kind that you are going to use. We have metadata, which is identifying the name and other metadata properties. And we have spec, which is the API specification. And if you find yourself writing YAML files to work with OpenShift, you typically need to figure out what you can use in this spec. Now, how do you do that? OC Explain deployments.spec will tell you. You can zoom in once you have found what is available. And what do we see? We see that in the deployment spec, there are some specific properties: min, ready seconds, and pause, and progress deadline, and replicas, and so on. And there is template. You want to know what you can do in template? Make that OC Explain deployments.spec.templates. And there you can see that, oh, in the template, we have yet another spec. So you add that, and the deeper you get, the more information you can add. OC Explain will tell you what you can use and where you can use it. And as such, OC Explain is a very useful help in getting the information in your YAML file that needs to be in your YAML file. Instead of using OC Explain and go there step by step, you can also use OC Explain --recursive on deployment.spec, for instance. And what do we see? Well, we see recursively everything that you can put in these YAML files. The ability to write your own YAML files is a very important ability. You definitely need to know how you should do that. And well, if you use your OC explain with the minus recursive option, you can see what can be used and where it can be used. And as you notice right here, it can be a lot of information. Now back to the original question. The original question is there anything different between deployment and deployment configs? Well, there's an easy way to figure out. First, let's get back to the API resources. What exactly are the API resources? So there I can see we have deployment configs in app.openshift.io. So if I use OC explain on deployment configs, at first level, we don't see many differences. The differences should be at the spec level mainly, because that is where you further define what you want to do in there. And there we can see that the deployment config has all of this as the spec. So min ready seconds, pause, replicas, revision, history limit, selector, strategy, template, test, and triggers. Now, if we compare that to OC explain deployments.spec, there we can see that, oh, there was a test and a trigger, wasn't it, in the deployment config? I don't have test and trigger in the deployment. Now, what does that mean in real life? In real life, that means that deployment and deployment config both can be used to define your application. But if you define an application using a deployment config in the API specification is capable of using stuff that does not exist in the deployment. So you can't just run your deployment config as if it were a deployment. You need to rewrite your YAML code if you do. And in the end, that is what it's all about, the YAML code. So once more, the YAML code for my pod. My pod is very simple. Just to provide you the basic information, here we can see the YAML code for writing pods. But hey, just a reminder to self, you already know about your Kubernetes basics. So I'm not going to explain how to write YAML files if you don't mind. I expect you to be capable of doing this yourself. And just some reflection on the EX280 exam. The EX280 exam does give you access to the OpenShift documentation, but not in an HTML easy searchable way. So my experience on the EX280 exam is that the way how they present the documentation is not very strong, to put it politely. And it really helps if you have knowledge about other ways to get information out of your resources. OC Explain can help, and OC Explain is an important skill on the exam. All right, that brings us to the end of lesson 3. Any questions? Any comments? Any whatever? So far, so good. Well, thank you very much for actively participating, Nazar. I do appreciate that. Bart is asking if you can use Helm on OpenShift. Yes, you can. I think operators are replacing Helm in OpenShift version 4. Maybe somebody else has an opinion about that, but Helm is becoming less significant. Operators are becoming increasingly significant. I am going to put up the slides for lesson 4. In lesson 4, we are going to start the stuff that is a little bit more interesting. Storage, it is. 29 slides about storage. I've been speeding up a little bit on lesson 1, 2, and 3. You can skip lesson 2. Lesson 4, we should take our time, I guess. So here we go again. Have you checked already? Everybody, I can't help myself, but I need to repeat my kindly request. Please consider making a donation to the Living Open Source Foundation. The Living Open Source Foundation is helping people that need help in getting their education. And we can make sure that talented people get funding for an exam, for example, or they get a new laptop if their old one is broken. And once it is possible to travel again, we do on-site stuff as well. Nazar, thank you very much for making a donation. Really appreciate that. Of course, it's not mandatory to make a donation. I just keep nagging about it with every new lesson that I'm opening. Because nice initiatives like this can only live if they have a broad foundation. Right, container storage. What is container storage about? Well, if you go back to your Docker fundamentals, then you probably know, oh, disclaimer, Docker is not the only type of containers. I should say container fundamentals, especially in a Red Hat-oriented course, right? But if you go back to your container fundamentals, then you know that containers are running instances of a container image. This container image is typically multiple layers, and all of these layers are read-only. But after starting the container, you get a read-writable layer that is added on top of the container. The read-writable layer, excuse me, the read-writable layer typically is stored somewhere in var lib on the host that currently runs the container. And thanks to the read-writable layer, you can write modifications to your configuration files. So far, so good. But now consider container storage in a clustered environment. You have your container currently running on node worker 1. And you make your modifications. That means that your modifications are written to the read-writable layer currently stored on node worker 1. And that doesn't make sense. Because in a clustered environment, your application might be running on another node tomorrow. And if the read-writable layer is not stored there, then your modifications are gone. And that's a problem that we need to fix. By the way, this behavior is what is referred to as the ephemeral nature of container storage. So ephemeral means it's host bound. And apart from that, upon deletion of a container, all files and data inside are also deleted. If you want to work with storage in containers in a more flexible way, containers can use volumes or bind mounts to provide persistent storage. And persistent storage, the idea is just about decoupling. Decoupling means that you want to make sure that your storage is not stored inside, but outside of the container. And the container just as a pointer to your storage. Now, if you look at containers alone, bind mounts can be used in standalone containers. If you study Docker storage essentials, then a bind mount is all that you've got. And a bind mount means that the container is making a bind mount to it directly on the host where the container is running. But that is not very cloud, because in a bind mount, you are still bound to your current host. And you don't want to do that. And that is why in an OpenShift environment, we need volumes. The volumes are needed to really decouple the storage from the container. Because using volumes guarantees that storage outlives the container lifetime. It is like using a SAN in a traditional data center. You know, it's a traditional data center dilemma presented in a new way. In the traditional data center, you didn't want to store your files on your server, because your server burns down, you don't have files anymore. And that's why we are using SAN in traditional data center to decouple and make sure that your files are stored somewhere independently. And that's exactly what we need to do in an OpenShift environment as well. We are using volumes to guarantee that storage outlives the container lifetime. Right. I want to make a drawing before we continue. You should see my drawing application again. Let me open a new drawing. Thanks for confirming. Right. If you look at the pod, this is the pod. We are not focusing on the entire application. We're focusing on the pod is good enough. In a pod, we have a container. And within the pod specification, you can define a volume as well. In entry-level classes, people are often asking, what's the difference between a pod and a container? And then I answer that the pod is adding features that are useful in the cluster. And one of these features, very important, one of these features is the volume. Now, these volumes can direct to anything. You can go to local storage, you can go to SAN storage, you can go to cloud storage, you can go to whatever kind of storage, and you can use PVC. Let's talk about PVC, persistent volume claim. What is the idea? The idea behind all of this is that the pod is your application. We are living in the world of new IT. In this world of new IT, application vendors are no longer distributing exe files that people need to install on their Windows servers. No, application vendors are distributing pods. And the pods is a ready-to-run container, and as Kubernetes is the standard. If you have a decently developed pod, then your customer only needs to run the pod to get access to your application. But if you are an application vendor, you're a developer, and you want to distribute your application, then sure, you can create a volume inside your pod, but the volume cannot have anything that points to specific local storage. I mean, as the application developer, you don't know if your customer is going to use local storage, SAN storage, Ceph storage, cloud storage, or whatever kind of storage. And that is why there is PVC. PVC stands for Persistent Volume Claim. Now let me explain how Persistent Volume Claim works. We have the application developer developing a pod, okay, and distributing the pod, and the end users are going to use that pod. Then we have the site administrator, and the site administrator is going to define within his cluster a persistent volume, or PV. Now, what is a persistent volume? Simple. A persistent volume is what allows you to get to a specific volume. So in the persistent volume, you are going to define that you are using Azure file, for example, or whatever you are using in your environment. So your storage specifics are in the persistent volume. And you have all of these properties that you need to define to connect to your local storage, like cloud credentials and I don't know what. So the site administrator creates a persistent volume. The application developer creates a persistent volume claim. What is a persistent volume claim? A persistent volume claim is making a demand for a specific amount of storage. And that can be a type, where typically your type is set to read only, read write once, or read write many. And you set a size, where the size is, well, any size that you need to be using in order to run your application, for example, 2 gigabytes. So what is happening? As application developer, you give your customer a persistent volume claim and a pod that is using a volume of the type PVC. This PVC is demanding, hey, I need read, write many, 2 gigabytes. And then you run it in your cluster. And while running it, you are going to query, is there any storage available that meets these requirements? And then when you run it in one cluster, it will find the local Azure file storage. You run it in another cluster, it will find the local Ceph storage or the GCE disk storage or whatever type of storage is available. And this is how storage is happening in an OpenShift environment. So what you need to know about is PVC. Now let's do it in order. You need to know about pod, about persistent volume claim, and about persistent volumes and how they all are working together. This is the main thing to remember. There are details to be filled in, but this is the main thing to remember. Now let's get back to the slides and let's see what the slides are saying about it. So back to main screen, you should see my slides again. So understanding OpenShift storage. OpenShift uses persistent volumes to provision storage. I just explained what these persistent volumes are. Storage can be provisioned in a static or in a dynamic way. And static provisioning means that the cluster administrator creates persistent volumes manually. Dynamically means that storage classes are used to create persistent volumes on demand. OpenShift provides storage classes as a default solution, and developers are using persistent volume claims to dynamically add storage to the application. So what is a storage class? Well, it's very simple to understand. Storage class is your default storage. And by using storage classes, you make it yet a little bit easier for your developers, because if storage classes are available, then you don't have to do anything anymore on your cluster. And using storage classes makes sense because remember, not all OpenShift instances are on user-defined infrastructure. Many OpenShift environments are running in a hosted cloud environment. So if you are using the Azure hosted cloud alternative of OpenShift, then in Azure you will have your Azure disk or Azure file as the default storage. And this default storage, that is your storage class. And these storage classes make that you automatically get your persistent volumes. And if you automatically get your persistent volumes, then there is only one thing remaining, and that is the need for defining a persistent volume claim. Right. I hope this makes sense. Probably something where you just need to see some more details. So let's just continue. Oops, I forgot to open the read-writable version on my other laptop. Give me a second. Using pod volumes. This is the part where I've been lazy. Nts Demo. That means that I'm going to demonstrate pod volume storage instead of walking you through slides. Just a side note, might be interesting, maybe not at all, but I'm going to say it anyway. I always have a hard time using slides in the right way because slides, it's so easy to create slides that are overloaded with information. But if you have a slide overloaded with information, it's so difficult to keep your attention to it. So my intention is to be very low on the slides and use drawings instead and demos instead. And if it's something easy like pod volumes, then, well, why would you bother about using slides at all? So do I have an example? Maybe my pod is an example. Oh, did I already tell you about the Git repo. I think I did not. What you might want to do is git clone https:// github.com/Sander van Vugt/EX280. Notice that I might change the name I'm going to use for the Git repo in the end, because I don't want to piss off Red Hat. But yeah, if you want access to the files that I'm using, this is where you can get it. I'm going for the different approach. I am going for, not Git, for OC explain pod.spec.volume, or was it volumes with an S? Volumes with an S. So we are first going to talk about pod volumes. Do remember what we see here in the pod volumes properties, something that is perfectly legal to specify in the pod. If you specify it in the pod, then you have a pod that will only run in a cluster that meets that specific volume requirements. That's not decoupling at all. But hey, let's face it, you might not care about decoupling. Depends on the role that you've got in this story. So what do we see in the pod volume? Well, we see the definition of the type of storage, including AWS, Elastic, Azure Disk. Well, let's just call it cloud storage, okay? Then there is CephFS, which is basically also cloud storage, but not bound to one specific vendor. And Cinder, which is OpenStack storage. Config map is something that we are later going to talk about. And we have some other storage types as well, like emptydir. Emptydir is perfect for testing because emptydir will create a temporary directory on the host that is currently running your pod. That is not cloud, not scalable at all, but if you want to test your storage, that's okay. FC for fiber channel, I'm not going through them one by one, just picking out a couple of them. Hostpath is also very common for testing. You create a host path on the host currently running your storage, or iSCSI, where you are going to connect to an iSCSI SAN, or NFS, where you are going to connect to an NFS storage environment, or you name it, like Photon persistent disk. Photon is the VMware Core OS alike thing. So you name it, many storage types are available. And you can do that in your pod specification directly. Do I have any pods with local storage? I don't think I have that here, but maybe I should just copy. This is me talking to myself. If you want to do it, CKAD instead of EX280. That is what you need to git clone. I have that locally on my file system, so I'm going to copy it from the local file system in documents. CKAD, more volumes, that's the one I need. Let me just give you the link, or the git command. https://github.com/Sander van Vugt/CKAD. Motion, isn't that depending on the client that you are using? But hey, I think you are right. With the .git, it will always work. Without the .git, it works on Linux. Is there anything else? But there you go. And that should give you a couple of things, including more volumes. What do we find in more volumes? Well, in more volumes, you can see this morvol2. Morvol2 is running 2 containers. That's a different story that I don't want to talk about right now, whether or not it makes sense to define multiple containers. But here we can see the rough structure. We can see that in the pod specification. So at the same level as a container, which means that the volume here is not a part of the container. It's a part of the pod, not of the container. So we define a volume. The volume name is test and the type is empty there. Empty there, as I was mentioning, simplest type of volume that you can define. Then you have your containers, containers CentOS 1, containers CentOS 2, and these containers are using volume mounts. And the volume mounts is presenting a mount path to the specific container for you. And that makes that I can use OC create -f more volumes.yaml. Need to give it a little bit. And then cat on more volumes. What do I need? I need to test CentOS 1 on the container CentOS 1 and CentOS 2 on the container CentOS 2. Okay. OC exec -it -it on more vol 2 -c CentOS 1 touch /CentOS 1 /my file. I think this should be working. It's downloading CentOS 7 image. CentOS 7 image, I think that's about 200 megabytes. So I'm trying to slow down a little bit so that I'm pretty sure that the file is available. Let's try it right now. It's not complaining, so it should be okay. So what did I just do? I just created a file with the name myfile in the directory CentOS 1. As we can see, CentOS 1 on this host CentOS 1 is using the volume test, and this volume test happens to be available in CentOS 2 as well. So OC exec -it more vol 2 -c CentOS 2 --ls CentOS 2. And what do we see? Yay, we see that my file exists. Well, Motion, this is not really something that I would call a sidecar container. Motion is referring to the multi-container pod scenarios where different scenarios are distinguished. But really, that's not something we should discuss in this class. It's too much Kubernetes and not OpenShift enough. What we should focus on is that here we have two containers writing to the same volume, and because they are writing to the same volume, they can access the data. Right, next topic, decoupling storage with persistent volumes. So what is this about? This is about persistent volume and persistent volume claim. I'm going to finish this before the break, and after the break we can continue to talk about storage class and make it more complicated. But we should know most of this already. So persistent volumes provide storage in a decoupled way. That's what I just explained. You don't want the knowledge about the storage infrastructure within the pod. You want it outside of the pod so that you can delegate it to the cluster administrator and the developer does not have to know about it. So administrators in this case create persistent volumes of a type that matches site-specific storage solution. And alternatively, storage class can be used as a default persistent storage. We'll talk about that later. Persistent volumes themselves are available for the entire cluster and they are not bound to a specific project. We were talking about namespaces earlier. And if end users create resources, these resources typically are namespaced. If administrators are creating resources, these resources aren't always namespaced. Cluster resources such as persistent volumes can be accessed no matter where in the cluster you are. All right, then there's persistent volume claim. So the developers can define a persistent volume claim to add access to persistent volumes to their applications. And then the pod volume uses the persistent volume claim to access storage in a decoupled way. And the persistent volume claim does not bind to a specific PV, but it uses any PV that matches the claim requirements. This is something that is very important to understand. There is no direct relation between a specific type of storage and the persistent volume claim. It's dynamically taken care of. In that situation, you can also find the situation. It sounds weird, but hey, you understand. In that situation, you can also find that no matching PV is found. And if that is the case, the PVC will wait until a matching PV becomes available. And when a matching PV is found, the PV binds to the persistent volume claim. And once it is bound, it cannot bind to another PVC. Right, here is a demo. And in this demo, what are we going to do? Well, first, SSH -I on tilde/.crc machines crc ID_RSA core at crc IP. Again, the problem is that we are on CoreOS. In CoreOS, you have a default user with the name Core. This default user Core does not have a password. The only way that you can access the CoreOS virtual machine is by using the SSH private key. This SSH private key is created in your home directory .crc machine crc ID_RSA. And this is the command that I'm using to connect using this SSH private key to the CoreOS virtual machine. So I'm in the CoreOS virtual machine right now. There I'm going to use sudo -I because I want to use storage. I think in this demo I'm going to use Hostpath storage, but if you want to use Hostpath storage, you need some storage device to be available. And this is the part where I am on my CoreOS virtual machine making sure that some storage device is available. Now, CoreOS is a world on its own, and I don't want to explain every gory detail about CoreOS because I'm not ready yet to do so. But what I do want to do, I want to provide some local storage. Now, in CoreOS, you should know that there's only a limited number of directories that is writable. And that is why I'm going to the MNT directory. You can do this in the MNT directory, you can do this in the TMP directory, and that is it. I'm going to use dd if equals dev0 of equals loopback file, bs equals 1m, and count is 1000. So what is this doing? This is creating a 1000 megabytes file in my CoreOS MNT directory. And then I'm using lo setup -fp on loopback file. What is lo setup doing? Lo setup is making sure that there is a loop device. So I'm using ls -l dev loop 0. And here we can see the dev loop 0 device exists. Then I can use my exit, and then we can have a look at the PV, the PVC, and the PV pod. So pv.yaml. I mean, we are building a structure where we are working. Oops, I need to do one more exit. So pv.yaml. What do we see? We see that I'm using persistent volume. The persistent volume, yeah, that's the kind. The name of the persistent volume is PV volume. Now we have a label, type is local. We have a capacity, storage is 2 gigabytes, and the access mode is read write once. And the host path is MNT my data. I think that is wrong. I think I'm referring to the wrong files here. Let me check. Let me check. I created something else. Grab persistent in star. And oops, I think my something else is still living on some other virtual machine. And did I destroy that virtual machine, or what did I do with it? Shit. This might be a nice moment to start our break. I need to look up my virtual machine, and I want to have a few additional minutes in my break. 15 minutes this time, everybody. And hopefully after the break, I have found what I'm looking for. See you in 15 minutes. All right, everyone, time to get started again. So I did investigate what's going on in my storage, and it happens to be this problem in my nodes and not in my storage. So no worries at all, and we can just continue where we left off before we went on our break. Which means that I will show you this PV and PVC and PV pod, and we are going to try to understand what it is doing. So to start with, pv.yaml is a YAML file where we create PV storage. And the PV storage in this case is using the type of Hostpath. Hostpath, as I was mentioning, is a temporary directory, and this temporary directory is created on the host. Just to make sure you understand which host, especially in a CRC environment, you might be confused about that. The host that it is going to create the Hostpath on is the CRC virtual machine. So don't make the mistake of thinking that this is on the machine where you are using the OC command, but really you should be looking for this on the CRC virtual machine. To create it, OC create -fpv.yaml. And next we can use OC get pv. No, Bart, no. It should not be MNT loop 0. You probably just missed, Bart, that my nodes are off, and the demo itself should be good. So I'm using OC get PV, and OC get PV is showing me a list of all the PVs currently existing, in which we can see that a lot of PVs exist, have been created automatically, but the PV that I need at this point is PV volume. We are just going to ignore all the other ones. So PV volume, that's what I'm going to be working with. Then we have PVC, which is another YAML file. And in this YAML file, we can see what the typical persistent volume claim looks like. So the persistent volume claim has a name, PV-claim. Remember the name, because this name is going to be important for the next part of the demo. We can see in access mode read write once, and resources request storage 1 gigabytes. So what are we going to do? Well, OC create -fpvc.yaml, and that is going to create the persistent volume claim. Notice that the persistent volume claim has no relation directly with whichever type of persistent volume. It's just going to look on the cluster for read-write once 1 gigabyte of storage available. So there is no guarantee whatsoever to where the PVC will end up. Next, we have PV-pod. In PV-pod, we are bringing everything together. So again, we have pod storage. This time the pod storage is in user share Nginx HTML. The pod is mounting PV storage on that. PV storage refers to the volumes. So we see the name PV storage, and PV storage is using the persistent volume claim name PV claim. So here we have a hard relation directly to the PV claim, and that is going to provide storage within this pod. So OC create -f pv pod.yaml is going to create it. And now if we use OC exec -it pv pod --sh, then we run shell. Oh, maybe I'm too fast. OC get pods running. OC exec -it pv pod. Yeah, that's doing better. Now I'm using touch of user share nginx html index.html, and the result is that I've just written a file to the persistent volume claim, wherever the persistent volume claim is bringing us into. If you want to see how that is working from a pod perspective, then OC describe on pods not vol2 pv pod is showing us that it has two mounts. So OC share nginx HTML from PV storage is currently being mounted. And if you want to further investigate, well, OC get PVC is showing that the PV claim has a status of bound. Can we figure out where that's coming from? OC describe PVC PV claim. And there we can see that there's a status of bound. But apart from that, we can't really see what it is bound to. It's bound by controller, and that's about it. And if you use OC get PV pipeless, then we do see the bind back here. So what do we see? Oh, we can see that we have a claim, my product PV claim, and the claim, my product PV claim, is bound, and it is indeed on PV volume. So it all ended up right, and the PVC is bound to the persistent volume that I've just created. And that's what I wanted to show you in this example of simple usage example, PVC and PV. Right, if you have any questions about this, then this will be the moment to ask. And if not, then we are going to investigate how we can make this more complicated. That is why, if there's any doubts about what we are doing at this point, please ask. Because if you're lost already, then it's not going to be better in the next part of the explanation. Motion is asking, does it support config map as a volume? Yes, it does, Motion, but I will talk about config map separately later. Because first I want to make sure everybody understands the notion of connecting to a specific type of storage. And then I'm going to confuse people even more by explaining that the config map can be a type of storage as well. We will get there in a little bit. The reason I'm doing it later is that if we talk about config map right now, it's difficult to keep an eye on the big picture and everything that is possible. All right, apart from motion, I don't see any questions coming in. So we need to talk about storage class. So what is this? Persistent volumes are used to statically allocate storage. Statically allocate storage means that there must be somebody who's doing the allocation. Storage class is what you can use to allow containers to use default storage that is provided in a cluster. And having a cluster with default storage totally makes sense, especially in cloud environments. So from a developer perspective, it doesn't make a difference, as the developer uses only a PVC to connect to the available storage. And based on its properties, PVCs can bind to any storage class. And you can set a default storage class to allow developers to bind to the default storage class without specifying anything specific in the PVC. And if no storage class is set, the PVC needs to specify the name of the storage class it wants to bind to. And you can set a storage class as default using OC annotate, but maybe we should check OC get SC. And what do we see? SC is short for storage class. We see that in this configuration, there is no resources found in my product namespace. How about OC get SC minus A? Minus A, which is doing cross namespace search for storage classes, is also giving nothing at all. Now, why is that? That is because of storage class provisioners. What is this about? Well, in order to create persistent volumes on demand, the storage class needs a provisioner. The provisioner is a program that is running behind the storage class and making sure that at the moment that you are going to work with the storage class, the storage is actually dynamically going to be created as well. And in order to do that, there's a couple of default provisioners, and these are AWS EBC, Azure File, Azure Disk, Cinder, GCE Persistent Disk, VMware vSphere, and that's it. So what does that mean? That means that if you want to automatically provision storage in an OpenStack environment, did I say OpenStack? OpenShift, in an OpenShift environment, then you need an environment that supports one of these provisioners. And unfortunately, if you are going to work with CRC, in CRC, there is no easy way to work with any provisioners. The choices really are for cloud storage or VMware storage or Red Hat storage. Cinder is using Red Hat storage, but an easy open source storage class provisioner does not exist. How about NFS? Well, that brings me to the next slide, which has never gotten out of the beta version. Bart is asking, why don't I see CSI? Bart, I have two options. Option 1, because it's not supported. Option 2, because I have missed it. If you have any proof that is pointing to me to a location that's convincing me that I have missed it, please share. Otherwise, it's not there. Okay. Yeah, Henry, I think you have a valid point there, because Ceph should be in there. And I am going to make a note to myself. Henry, I can't answer that one right now, but Ceph is Red Hat Ceph storage, and Red Hat Ceph storage should be included. I've made a note, and hopefully I have news about that tomorrow, Henry. Let's talk about NFS, because in test environments like this, NFS will be an awesome type of storage class. And well, this is what I've got. But Motion, I need a link. I need a link that shows me that GlusterFS and Hecate are available as a storage class as well. Can you please provide that? Preferably by email, so that I can update my slides. I would much appreciate if you can do that. Right, NFS persistent volumes. For storage class to be truly dynamic, you need to create these persistent volumes automatically. That's the task that's the task of the provisioner. Many of these provisioners are difficult to implement in a simple test environment without bringing in a lot of other stuff. And that is why you would like to use an NFS storage provisioner. And in order to use NFS, there are two options: add a third-party operator or custom provisioner to automatically manage NFS persistent volumes, or use Ansible playbooks to provision a pool of static NFS persistent volumes, and if the cluster needs new NFS persistent volumes, rerun the playbook. I don't consider the second option a valid option, but I do consider the first option interesting. Let's get back to CRC console, where in CRC console we have the operators, and in Operator Hub I want to show you what I've been investigating, but let there be no doubt about it, I have not been able to create a working environment. So don't get overexcited here, because in the end it will fail. This is also not doing very well. We tried it again. Do I want to update? Yeah, I want to update. I want to quit Safari. And operators, Operator Hub. That's looking better. In Operator Hub we have storage, and here you can find these different storage provisioners. And in these storage provisioners we have, where is it? Oh no, hang on. I think I'm making a mistake. This is not available in Operator Hub. No, let's skip this. This doesn't make sense. And let's just summarize it with, I've been trying to create an NFS provisioner. There are some people on the net who say they've got it working. I've not been able to reproduce. So that's all I want to say about it right now. If any one of you has successfully implemented an NFS storage provisioner, I'd be more than interested. But assuming that it's going to be hard, let's just skip over this and continue with config map. I'm afraid that our reality in our EX280 CRC based test lab is that we will need to do without storage class because of a lack of options to configure storage class. This is on my to-do list, but for now, no success yet. Let's continue and let's talk about config map. Config map is a very interesting resource in Kubernetes as well as in OpenShift. The purpose of config maps is to decouple information. Decouple information, that means that config map can be used to provide information that you don't want to hard code in your pod environment. Because the generic perspective is that the pod is something that you want to provide to your customers maybe. And in the pod you cannot have site-specific information, but sometimes you do need site-specific information, like command line parameters, like variables, like config files. And in order to provide that site-specific information, you are going to use the config map. So how does that work? Well, first, you need to realize that config map can be used for different purposes, and according to the purpose of why you are going to use a config map, you are going to use a different approach. And that's kind of confusing about config maps. So what can you do? Well, you can do three different things. They all start with kubectl create CM, which is creating the config map. After that, you specify the name of the config map, and then you specify where you want to create the config map from. Your options are -- from file, -- from env file, and -- from literal. But before we continue trying to understand these options, you must understand that config maps can be used for different purposes. You can store environment variables. You can store configuration files. And these are totally different approaches. If you are going to use a config map to define environment variables, you need to make sure that the pod that is going to use the config map is going to use it as containing environment variables. If you are going to use a config map to provide access to a configuration file, that's a completely different approach. But before you start worrying about that, you should make sure that you know that there is 3 different ways of creating your config map. From file, from end file, from literal. Where from file is what you are going to use for the config file. From end file is an environment file that contains environment variable definition in a key equals value format. And from literal is to define variables or command line arguments just on the command line. Typically used for environment variables. Now I have three demos about that, and I think we are just going to run all of these. By the way, these 3 demos are a shameless plug from my CKAD class. That's why you see kubectl instead of OC. That's something I still need to change. Let me run OC instead of kubectl. So starting with demo number 1, OC create CM variables dash from no, before we do that, I need to check that we have this environment file. Are we in the right location? We are not. So let's get to the right location. And I don't have my variables file. I can fix that by using CP. You remember the CKAD Git repository that I was talking about earlier? You should have it because I'm borrowing from the CKAD Git repository a lot in what I'm doing here. This is not yet in my Git repository, but get to CKAD, you should be all right. So CKAD and variables, copying that to here. So here we have the variables file. And in this variables file, we have var1 is hello, var2 is world. Based on that, I can use OC create CM variables dash from env file is variables. And there we can see it has created the config map. Now, if we use OC describe CM variables, then we can see the contents. And in the contents of the config map, there's a data section. And in the data section, we have variable 1 with the value hello. We have variable 2 with the variable with the value of world. Now I need CM test pod. Do I have CM test pod? I also need to copy that one from my other GitHub repository. So CM test pod, and let's put that in here. Let's have a look at CM test pod. What do we have here? We have a simple YAML file. The simple YAML file is creating a pod with the name test1. And this pod is running the command that prints the environment. The important thing here is env from, because env from is telling the pod where it should get its environment from, and the environment should come from config map ref. And config map ref is how you tell a pod to get its environment variables from a config map, and the name is variables. So here we tell the pod, hey, read the config map variables, and then you got your variables. So we can use kubectl. No, not kubectl. We are using OC in this class. So we can use OC create -f cm test pod.yaml. And then we can use kubectl. We can use OC, OC logs po test. And Wasn't that test 1? Yeah, that was test 1. And what do we see? var1 is hello, var2 is world. As you can see, it's working. Yay! So this was config map example number 1. Example number 1, where we have obtained the value from an environment file. Example number 2 looks very much like this, so I'm not going all the way in this example. I just want to show you cubes oc create cm more vars minus minus from literal is var3 is goat and from literal is var4 is cow. I'm from Friesland, so I like cattle, in case you are wondering why it's using these names. So I created a config map with the name more vars, and now I'm going to use oc describe cm more vars, and there we can see that the variables are there. I'm not going to include that as well in a pod because it doesn't change anything in the procedure. Now, the interesting thing, and this is really something that you need to fully understand, is how we are going to use config maps for configuration files. Now, why is this so important? Well, this is so important because later we are going to talk about secrets. Secrets are an extremely important resource in Kubernetes for configuring other resources that need to be secure. You can put your security stuff in a secret, and a secret is like a config map on steroids. Which means that in your understanding, if you want to be able to create secured routes using TLS certificates, you are going to provide these TLS certificates using secrets. You are never going to understand what's happening there if you don't understand the config map. So what I'm going to demonstrate here is really very essential. And make sure you ask questions all the way until you are sure that you understand this stuff. Before I need to copy my my example files. What is it? Nginx custom config. That is one. And then let me check if we need anything else. Nginx cm. And that is it. Okay, here we go. So first, the file nginx custom config. This is an nginx configuration file containing nginx stuff. Who cares about nginx? You shouldn't, because really it's just a configuration file. Then oc create. By the way, before I continue, which kubectl, use a local bin kubectl, ls-l user local, we can do that more efficient, ls-l on which kubectl as well as which oc. And what do we see? Oh, I just wanted to see and check if they are the same binary or not. Well, here we have proof they are not. Good. Let's continue OC. So using what? Using OC create cm nginx cm minus minus from file nginx custom config.conf. Created. Now we are using oc get cm nginx cm minus o YAML, the YAML format. And what do we see in the YAML output? We see that there's a data section, and the data section contains the contents of nginx custom config.conf. And notice that this nginx custom config.conf is used as a key to specify the actual configuration that should be present in the configuration file. Next, we should have a look at nginx cm.yaml. And what do we see in nginx cm.yaml? We see that we have a volume in the pod specification. This is just a pod specification. The pod specification has a volume, and the volume has the type of config map. So this is at exactly the same level as Hostpath or mtdir or Fiber Channel or Gluster FS, but this time it is config map. And the config map that we are using here is nginx cm, which is the name of the config map. The key that we are using is nginx custom config.conf, which was the name of the original file, but which exists in the config map as the label for the configuration that we actually do want to use. And the path is going to be default.conf. So this config map is going to create a file. Where is it going to create the file? Well, have a look at the volume mount, where we can see that we have a mount for the name conf, and the mount path is etc nginx conf.d. So what do we have? The name conf corresponds to the name of the volume that we have here. When we address the volume, we are going to address the config map, which is right here. Within the config map, we are going to look up the key nginx custom config.conf, and that is going to create the file default.conf. And where is it going to create this file? It is going to create it in the mount path, and the mount path is etc nginx conf.d, and that is how it's going to work. I hope you realize that there's a lot of indirectness in here, and it is not that easy to understand, but this is typically something that you need to do a couple of times, or use a nice example, follow the example, try to understand, create your own alternative configuration, and you should be good. Okay, oc create -f nginx cm.yml. The thing is created. And oc exec -it nginx cm. We might see, by the way, that nginx is failing because of other reasons. Oh, it's not, it's even better. And I'm using a cat on etc nginx conf.d default.conf. And what do we see? We see the contents of the config map. So that is how a config map is mounted dynamically within a pod. I hope this makes sense. I do think, I don't see any feedback. You still around, everybody? Thank you, Nazar. Thank you, Josep. And all right. Do you want me to make a drawing in which I further explain all of these relations, or are you good? Shall I continue? Can you type drawing if you want to see a drawing, or continue if you want me to continue? Okay, drawing. I do see a couple of votes for drawings. So let me make a drawing. Drawing. Here we go. Where am I? My screen. I want to share my screen. Screen 2. No, I want both screens here. I hope it's readable if I do both screens. But this might make more sense. Where am I? Oh, I'm in the wrong location. Yeah, of course, motion is easy if you're into CKA. I know. If you are not, it's not. And as config maps are important for understanding secrets, and secrets are important for understanding at least secured routes, And without understanding these, you are never going to pass your EX280. I'm going to take my time to explain it anyway. Right, OC, no, I don't want OC. I want cat on nginx cm.yaml. There we go. Is it easier for you, by the way, if I just show only the screen with the drawing? Is it better from a readability perspective? Because if so, I am just going to show you just that screen. Both is fine. Okay, and then we keep both. So what do we have? We have this this config file, right? Config, no, not config file, config map. And the config map is what is happening again to my pen. Hang on, I think I need to reconnect. Yeah, it's better. Okay, so we have the config map. Let's call it CM, and CM is nginx CM. In nginx CM, what do we have? We have a lot of parameters, and one of these parameters, maybe I should just do an OC get CM nginx CM -o YAML, just to make sure that I'm not making any mistakes. So we have a key, and let me use blue for the key. This key is nginx, I'm calling it cc.conf, okay? So that I don't have to write everything. Oh, you have lost the drawing? I will fix that. This is better, isn't it? I think you should see both of them. So nginx cc.conf is getting there because we have used this file, and the name of the file is nginx cc.conf, and there we have what we call config. The config is a specific configuration. Right, then we have this this pod. I think I need to write this big. So we have the pod, and the pod name is, you could check that on the other one. There we go. So we have a pod with the name nginx CM. And in the pod nginx CM, we have a volume. And the volume is using, with all these different properties, I'm not going to write down the entire config here. This is just about understanding the relation. This is the nginx CM config map. So in the volume name, we make a connection where the pod is pointing to the config map. And in there we have an item. And in that item, we have the key, and the key, let's use blue, so that we have that name consistently, is nginx -c-c.conf. The thing is, in a config map, you can have multiple keys, so you need to specify which key as well. And by specifying to that key, you can import the data, but you don't do that directly. You do that at another level of indirectness, and that is where in the container you are going to use a volume mount. And the volume mount is using the name conf. Now, I should have written this name in the volume as well. So let me squeeze it in here, name conf. So in here, let me use yet another color. We make a connection between these two. And because we make that connection, the mount path, which is slash whatever, is going to create that file, and the file default.conf. Well, in order to get the contents of that file, in here we are going to look at the config map key. The config map key is sending us back and is fetching the data from here. So that's a lot of arrows, that's a lot of indirectness. I'm not even sure if this drawing made it any clearer, or just emphasized that it is kind of some decoupling here, but still, I hope this does make sense. You need to practice this. If you want to do homework for yourself for tomorrow, you need to practice this. You need to make sure you understand this. Yeah, Nazar, hands-on would help. Well, hey Nazar, let me return the question. In what way would you want to see the hands-on? I mean, this is a live class, right? We have the limitation that I don't have more than 2 times 5 hours, and I have a lot of explanation to do in this 2 times 5 hours. And I think you want me to reserve some time for hands-on exercises, but you know, if we do hands-on exercise right now, that would at least require half an hour of our time, and that goes off of all the topics we have still on the list for tomorrow. So the best thing, I'm afraid, that I can offer from a hands-on perspective is the end of chapter labs that you find at the end of all the lessons. And there is no way that I can do anything better, I'm afraid, than that, given our time constraints. I hope you understand, Nazar. If you have any suggestions on how I can make it better, then yeah, do let me know. And yeah, you should do it by yourself. Exactly. Good that we agree on that. All right, local storage operator. Now, what is the local storage operator? Well, let's try to understand. Operators can be used to configure additional resources based on custom resource definitions, right? The idea of an operator is that you are going to capture what normally a person is doing, but now you are going to do that through software. And different storage types in OpenShift are provided as operators. And local storage operator creates a new local volume resource, but it also sets up RBAC to allow integration of this resource in the cluster. RBAC is role-based access control. I will explain about role-based access control tomorrow. And the operator itself can be implemented as ready-to-run code, which makes setting it up much easier. And I wanted to give you a demo of one of these operators. In this context of storage, well, it might be nice to have a look at the local storage operator. So here we go. Do I still have my CRC console? I still have my CRC console. And in CRC console, I have local storage. There we go. So I am clicking on install. I need to increase the available screen size a bit. So for the remainder of this demo, I can't see what you are posting in chat. So I am going to click install, which is going to install the local storage operator. There we go. So what do we see? We see information about how to use it, specific namespace. So installation mode is either all namespaces or specific namespace, and operator recommended namespace. So it's going to create OpenShift local storage. Does not exist, will be created. And the approval strategy, that's for folks that want to use it, is going to be automatic. And then it is going to provide a couple of APIs, LV for local volume and LVS for local volume set and local volume discovery, and more of that stuff. So let's click install and see what that is doing for us. That always takes a couple of minutes. The result should be that the local storage operator is going to be configured for you. While it is doing that, I don't think it makes much sense to have a look at the progress indicator. So while it is doing that, let's have a look at the remainder of what I wanted to do. You can see that on the next slide. I am going to skip the first part on the next slide, which is create a block device on CoreOS CRC machine. This was the lost configuration that was in my previous demo. You remember the demo about persistent volume, where I was just wondering, what am I trying to do here? But in this demo, we set up a dev loop 0 device, and this dev loop 0 device is used by the local storage.yaml. So let's try to understand local storage.yaml. What do we see here? We see that we create a kind local volume. That's a new kind that exists because of this local storage operator, which is an API extension. This is not default in OpenShift. So we have the name, a local disk, and the namespace, OpenShift local storage. OpenShift local storage is the namespace where the local storage operator is created. And then we have the spec, and the spec is storage class devices. And oops, maybe I should change the name here, because the Dutch guys amongst us will notice that I've struggled a little bit before I got this to work. So we have a storage class name, which is good local storage, and volume mode, which is block, and device paths, which is dev loop 0. Let's see how far we are. OC get all -n OpenShift local storage. Oh, there we go. We have a pod, local storage operator. So this pod is addressing some software, right? An operator really is a running application. This running application is running in the way of a container in the Kubernetes environment. Now I'm going to use OC create -f local storage.yaml. And there we can see local volume, local storage, OpenShift, blah, blah, local disk created. And if we type OC get pods -n OpenShift, OpenShift local storage, then we can see that a couple new pods have been created. So the local disk maker, and the local disk local provisioner. That's what this is all about. This is about creating a provisioner that provisions storage based on local storage. And if you use OC get PV, then in OC get PV, we can see that a new local PV has been created. This relates to the storage provisioners that we've been talking about before. The storage provisioners, which are needed in a storage class environment. I was mentioning before that storage class depends on the availability of a provisioner, and the provisioners that are available are quite limited. But this local storage operator might give you an opportunity to explore the working of storage provisioners anyway. If you have a new RWO storage type, 1000 megabytes available, and that is what automatic provisioning can kind of look like based on this local storage operator. Okay, with that, it is time for our next break. And even if that means that our last half hour is only going to be half an hour, I think after 4 hours and 30 minutes of information about OpenShift, we all need a break. So I'm going to start the timer again. And this time I won't forget to press the start button. There we go, number one, and start, and I see you in 12 minutes. All right, everybody, I am back, and let's continue. Georgie, the time remaining application, that's just part of go to training. And don't see any other questions, so let's just continue. With this, lesson 4 is a wrap, and if you want to, you can do the lesson 4 lab as homework, not now. I have uploaded lesson 5. It was not here when we started earlier today, but now it is. And I want to make a start with lesson 5. We are probably not going to be able to finish everything, but let's at least get started with it. Right, the regular stuff, let's skip over that and let's talk about users. So this is about users. And we need to understand what the user is in an OpenShift environment. The nice thing is that users don't exist in OpenShift in the normal way of how you would normally see your user accounts. In OpenShift, we define a user as an OpenShift object who can be granted permissions in the system by adding roles to the user or user groups using role bindings. So we need 3 different components. We need users, which optionally can be a member of a group. We need roles and we need role bindings. The role is a definition of some access permissions, and the role bindings is connecting a user to a specific role. In OpenShift, there are no less than 3 different types of users. There are system users. System users are automatically created to allow parts of OpenShift to securely interact with the API. And these system users, they are just there and you don't have to worry about them. There are service accounts. A service account is a special system user, and they are associated with products to give additional privileges to pods and deployments. You should know that a service account is a specific API resource, so you will see them as API resources. I can give you OC get SA minus A, for instance, and then we can see the service accounts. And as you can see, there's a couple of them. And these service accounts allow your different OpenShift components to interact with whatever you want to do in your cluster. More about service accounts later. And there are regular users. Regular users represent people who can perform specific tasks in OpenShift. Let's face it, OpenShift user accounts is all about what a user can do in the OpenShift environment. It's the OpenShift environment that matters. Let's talk about a cluster administrator. Once you have installed OpenShift, there are 2 ways to authenticate API requests with administrator privileges. First, there is the kubeADM, a virtual user and password that grants an OAuth access token. Then there is the kubeconfig file that embeds an X509 client certificate that doesn't expire. So there's a default cluster administrator, and you can do something for yourself as well. Now let's have a look at the X509 certificate. How does that work? Well, when you create a cluster, a kubeconfig file is generated during the installation. And you can see that kubeconfig file. Let's have a look at the kubeconfig file. It is in home directory .crc/machines, in which we have a CRC, in which you can find your SSH keys, as we've talked about before, but also your kubeconfig. So if you look at the kubeconfig, in the kubeconfig, we can see the configuration. So we have API clusters, cluster. Here's a cluster definition with certificate authority data. That's a cluster certificate authority. Then we have the cluster server. We have the context, which is defining this admin user. The current context of the admin user is admin, and this admin user comes in with client certificate data. Now, what is the idea? The admin user is authenticating to the cluster based on the client certificate data that the admin user is sending to the OpenShift cluster. The OpenShift cluster is using its internal certificate authority to verify the integrity, and based on this SSL certificates, this user is going to be all right. Now, if you want to use this internal cluster user, that is something that you can do. You can use export kubeconfig. So you type export kubeconfig, as you can see on the slide. Export kubeconfig is a complete path to your kubeconfig file. And that will set your OC client to use the contents of that configuration file. Alternatively, you can also use OC --config followed by the name of the configuration file, followed by whatever you want to do, like get nodes, for example. This is nice, this is convenient, and this is what you are going to do after just installing your Kubernetes cluster. So how does that work? Authenticating with the virtual user. We call it the kube admin virtual user, and that's a hard-coded cluster administrator user. Privileges of this user cannot be changed. That's because it's a hard-coded user. And also the password is dynamically generated and hard-coded as well. You know that CRC installation is printing the password, and that's the password that you can use. Now, this is the default OpenShift administrator, and you can use it, but you should set up an identity provider and create a new user which has been assigned the cluster admin role, after which the hard-coded user can be removed. If you want to compare this to Linux, you could see it as follows. In Linux, you have a root user account. Okay, just consider this kube admin user a root user account with default password, and that's obviously not so very secure. So you should configure an identity provider, create a new user, assign that new user the cluster admin role, and then you can delete the hard-coded user. And that obviously is something that you should not do before verifying that the new account works. Because if you delete the hard-coded user, and then you can't log in anymore if you don't have an alternative entry point. If I may give you an advice for EX280, this is something that you want to practice and practice a lot so that you are really confident in case you might see it on the exam. And I know this might get a little bit too far, but hey, let's just imagine the imaginary situation where you take the EX280 exam. And on the EX280 exam, you need to delete your original virtual hard-coded user. I mean, when are you going to do that? Because if anything goes wrong, then you are in trouble. So make sure that just in case you might see it on the exam, you practice and practice a lot. Right, after setting up CRC, the login command that uses an auto-generated password is printed on screen. You can type eval crc ocenv to set up the shell, and then you can type oc login -u kube admin -p password on https API crc testing port 6443 to authenticate. We have done that already a couple of times. Now, if you want to be able to delete this hard-coded user, you need to investigate identity providers. And that's what we are going to talk about right now. So first we need to understand what this is about. This is about authentication and authorization. And you need to understand what exactly is involved here. So that's what I'm doing right now, what we are trying to understand right now by following the slides. So when you are accessing OpenShift cluster resources, a user makes a request to the API. And the authentication layer is responsible for authentication of the user. So authentication, and that's no different if you compare it to PAM on Linux, for example. Authentication is where the user comes in and says, hey, my name is Bob, can I get in? That's what we call authentication. Next, after the user has been authenticated, there is authorization. Because it's one thing to allow your user Bob in, but next your user Bob probably wants to do something, and that's authorization. In authorization, you use RBAC, the role-based access control, to determine what the user is authorized to do. And if API requests contain invalid authentication, it's authenticated as a request by the anonymous system user. Anonymous system user is just a nobody kind of user. Now, how are we going to authenticate? Well, in OpenShift, roughly, there are two authentication methods. There is OAuth access tokens, which uses access tokens to authenticate the request. And there is X509 client certificates, where TLS certificates are used to authenticate requests. Now, we need to know a little bit more about the authentication operator. The OpenShift authentication operator runs an OAuth server. So the OAuth server is a part of OpenShift provided by an operator, which is a default part of OpenShift. And it's a very important part of OpenShift. So this OAuth server provides access tokens to users that authenticate to the API. And the OAuth server works with an identity provider to validate the identity of the requester. And this server connects the user with the identity and creates the OAuth access token, which is next granted to the user. Hey, there is one thing that you need to understand here. We have OAuth. The purpose of OAuth is to generate access tokens, but OAuth is not the identity provider. The identity provider is where you get your identities, and OAuth will be configured to work with an external identity provider to validate the identity of this requester. And different identity providers are available. In this course, we are going to work with HTTPS-WD, which is your HTTP server authentication. HTTPS-WD validates usernames and passwords against a Kubernetes secret that stores credentials which are generated by the HTTPS-WD command. So HTTPS-WD, if you have ever configured an Apache web server, that is the HTTPS-WD that we are talking about. HTTPS-WD is relatively simple, and that makes it easy, relatively easy to use. It is not the only identity provider. There are other identity providers as well, such as Keystone, which uses OpenStack, Keystone server for authentication. Listen carefully, that is OpenStack, not OpenShift. Where OpenStack is the external cloud solution that was pretty popular a decade ago, but which is still used by many companies. You can use LDAP for an LDAP identity provider to verify your authentication. And as LDAP is a generic access protocol, you can use LDAP to communicate to Linux IPA, for example. Or you can use external identity providers like GitHub for the GitHub Identity Provider, or OpenID Connect, which integrates with OpenID Connect. And I wouldn't be surprised if at one day, sooner or later, OpenShift will be able to work with commonly used identity providers such as Google, for example. Ricardo is asking any SAML options. Not that I'm aware of, Ricardo, but maybe somebody else in the group can fill in. I do know there's some experience in this group, so if anyone has anything to add to Ricardo's question, please let us know. Right, let's talk about HTPassWD identity provider. Purpose of the class today, at least I want to make sure we understand HTPassWD, and then we are going to be able to work with some users. And then tomorrow we can wrap up the users and start with RBAC. But first, HTPassWD, identity provider. Now, what is HTPassWD? HTPassWD identity provider uses a Kubernetes secret that contains usernames and passwords which are generated with the Apache HTPassWD command. Hey everybody, a Kubernetes secret. What is a secret? A secret is a Kubernetes API resource. And this API resource is very much like a config map. You remember config map? We talked about config map in the previous hour. And we discovered that in a config map, you can store configuration files, but also variables. Well, in Kubernetes secrets, you do the same. And Kubernetes secrets are mainly used for storing variables, but variables that have values that have a sensitive value, like web keys, for example, like SSH private keys, like TLS keys, for example. So HTPassWD is going to create a Kubernetes secret that contains usernames as well as passwords, which are generated with the Apache HTPassWD command. And using this identity provider is recommended for small proof of concept environments. So the HTPassWD identity provider is not fancy, it's easy, and that's exactly why we are going to use it here. In large environments, you want integration with the organization identity management system, like IPA if you're on a Linux environment. Now, how does this work? Well, to use the HTPassWD identity provider, you need to configure the OAuth custom resource. So OAuth is this operator that's already available in your OpenShift cluster. And we need to teach OAuth which identity provider to use. So this OAuth should contain, let me fix that, spec.identityproviders.htpasswd in the list of identity providers. And an example OAuth YAML file is provided in this course, but you can easily generate it yourself as well. Am I not showing you how to generate this? Oh, apparently not. Oh, yeah, I do that in the next slide. I'm just getting confused by the way how I have organized these slides at this point. Right, OAuth custom resource. This is what I want to show you right now. So PWD, where am I? Wrong location. I want to go to EX280. Where you can see that an OAuth.yaml file is provided. And what are we going to do in the YAML file? Well, first we need to understand how we get to the YAML file. get OAuth. I want to show you the OAuth resource. We have one OAuth resource, which is the cluster resource. So get OAuth cluster -o YAML, which is generating YAML output. And let's call it new OAuth.yaml. And if you look at new OAuth.yaml, what do you see? You see this metadata stuff. Go beyond the metadata stuff. What matters here is the spec. And in the spec, we can see we have an identity provider, HTTPS WD file data name HTTPS secret. So what is this? This is where OAuth is being told that it should use the HTTPS WD identity provider. And this identity provider is getting its information from an HTTPS secret. That's basically how it works. But of course, this is only going to make sense when you see the complete picture. On the exam, you should be prepared to modify the currently existing OAuth identity provider based on the documentation you will get there, and you will modify it so that it's going to work with the right identity provider. I have already set this up and I've played with this before, which is why on my configuration there's nothing to do. If you're going to do the exam, then definitely you need to change the information that you see right here. How about this HTTPS WD secret? Well, this HTTPS W secret, as I will show you, is a secret that contains the information about your users and such. If I use OC get secret minus A, then oh no, we see a lot of secrets. What was the name of this secret again? I need to look it up. HTTPS WD. So OC get secret minus A pipe grab HTTPS. There we can see that in OpenShift config, there's an HTTPS secret. And this HTTPS secret, that is where you store your user information. So OAuth knows that it needs to fetch additional information from the HTTPS secret. Everybody, I hope you see the similarity between this secret and the config map that we have seen before. The config map was used to provide environment variables. Here we are a little bit more specific. We are providing, well, environment variables which contain usernames. So let's talk about creating and deleting users. There we go. So first, you need to understand the procedure. Creating users is a two-step procedure. After you have configured the OAuth identity provider, you are first going to use HTTPS WD to update the contents of the HTTPS WD file. Then you create a secret that contains the contents of the HTTPS WD file, and next you tell the OAuth provider to use that secret contents. And to add users, contents of the secret must be extracted to a temporary HTTPS WD file or newly generated. And next, the HTTPS WD command is used to update that file, and the secret is newly generated. And after creating the configuration, the OAuth operator deploys authentication pods in the OpenShift authentication namespace. So, hey, this is an operator, right? And an operator, as we have seen before, is not just code in your OpenShift cluster. It is also software that is running, as a pod. And I am just going to show you how that works. So here is demo part 1. The demo continues on the next slide. And I'm going to run you through all of that right now. First, let's do HTTPS WD minus C minus B minus B on slash TMP HTTPS WD admin password. So what is this doing? HTTPS WD, be careful, minus C creates a new HTTPS WD file. That means it will overwrite anything currently existing. Minus B is just taking care of reasonable, fancy encryption. It's not really very important, just a parameter. Next, hcpass wd minus b tmp hcpass wd ANA and password, and then we are going to create Linda with a password as well. And now we have an hcpasswd file. So cat on tmp hcpasswd is showing that we have these three different users. So based on these three different users, we can continue. And how are we going to do that? By using OC create secret secret generic hcpasswd secret. Notice that the name is not random and it needs to match what you are using in the OAuth configuration. Minus minus from file htpasswd is /tmp /htpasswd minus n OpenShift config. So that is creating the secret, right? So we have a new secret with the name hcpasswd secret. Notice that in the OC create secret, you use OC create secret generic. Generic is a secret type. Then we have the minus minus from file. And the minus minus from file needs htpasswd equals. That is telling the secret to interpret the file in the right way. And minus n is just to tell it that the OpenShift config namespace is where you need to be looking for this specific secret. Next, we need to do something with it. So OC ADM policy add cluster role to user. Why am I doing that? Well, because just creating users without anything makes no sense. You create users to use them in role-based access control. So I am going to do that, and I am going to make sure that we have cluster admin for user ANA. Then it's telling you user ANA not found. That's normal. Ignore the message. It's also telling you cluster role RBAC authorization, and that looks as if it is going all right. Second part of the demo, second slide. We are going to use OAuth.yaml. I've already shown you how you can generate the YAML file. So let me just have a look at OAuth.yaml and make sure that we are using hcpasswd secret. Well, it happens to be that we are already doing that. That's good. So I'm using OC replace minus F OAuth.yaml, which will replace the current YAML file with the previous YAML file. And oh no, error when replacing operation cannot be fulfilled on object has been modified. Please apply your versions to the latest version and try again. What is it telling me here? Object has been modified. I think it is telling me that I already meet the conditions that I'm trying to impose here. So I'm just going to ignore the error message and I'm going to use OC get users. And what do we see? Oh no, I only see a developer user, but OC login minus U ANA minus P password. And there it's not working out all right. Shit, this is probably because I already did this configuration before starting class. So how am I going to fix this in a decent way? OAuth.yaml. And we are going to use htpass dummy. I want to know why it's not working. Yeah, Isaac, I am wondering if the version in the YAML for all of YAML needs to change. Yeah, that's a good suggestion. Let's clean this up. And let's get back to HTTPS users. That's the one. Thank you very much, Isaac. There was specific version information in the YAML file because I generated it. And now it is working. At least I've been able to replace the current OAuth configuration. And I am getting an error message on my user anyway. That's not so nice. OC get users. Let's try OC login. -u Linda -p password. And there we can see that Linda is successful. Anna is not successful. I'm not sure about Anna, but I'm happy that Linda at least is successful. So OC what? OC get nodes. What do we see on user Linda? Oh no, nodes is forbidden. User Linda cannot list resources nodes. How about OC get pods? And oh no, pods is forbidden. User Linda cannot list resources pods. Apparently user Linda is kind of a nobody user. How about OC login -u Anna -p password again? I'm not so sure what is wrong with user Anna, but hey, look at this. Now suddenly user Anna does work. Beats me, but hey, I'm happy that it's working. No, it doesn't beat me. I think I've just been too fast. When you do your OC replace, it is going to replace the current OAuth backing pods. Remember, these are the pods that are created in the OpenShift authentication namespace, and I think I've just been too fast. Now we can see OC login -u Anna -p password, and it works. And yay, OC get nodes. We assigned Anna to the cluster administrator role, and OC nodes is working, and OC get pods is working as well. So, oh joy, we have working user. OC get users. Do realize that in order to see your users, they must have successfully logged in once. Because by logging in at least once, an identity is created. If you type OC get identity, you can see the identities currently existing. Before logging in at least once, users don't have an identity. So you need to log in at least once, otherwise it is not working. And that is where I want to stop for today. 5 hours is a lot of time, and I think it has been enough for today. I would like to advise, try this before you are getting back tomorrow. Make sure that you are confident with this OAuth based user stuff, because many things that we are going to do tomorrow are going to continue building on this OAuth user stuff. Any questions before I'm wrapping up for today? Quick feedback would be appreciated as well. Don't have to put it in group. You may send it to me personally as well, either in chat or in email. Was it doable? Was it too much? What do you think? Isaac is asking if developer users should fail. I don't think developer users should fail. If we can try that, OC login -u developer -p developer. And oh yeah, yeah, of course it is failing. Yes, Isaac, of course it is failing because the change in the identity provider. The identity provider is now OAuth. HCPaaS users is what is used, and no longer HCPaaS provider. All right, everybody. I don't see any more questions, feedback, or whatever coming in the chat, so I am going to call it a day. I have been recording for today. Rendering the recorded files takes a lot of time, so I don't think I will be able to provide the recording before we are starting tomorrow. I will do that at the end of class. But yeah, for now, I would like to say thank you very much for joining me today, and I am looking forward to continuing tomorrow. I am out of here. Bye bye, everybody.